Hello everyone, welcome to the Gate Academy, right? So I hope your preparation is going well, right? So this is the very last time and few weeks are left for the Gate examination, okay? So at this moment, your preparation should be like this, that you have to prepare the subject in a revision mode, right? Whatever you are preparing for your subject, it should be in a revision mode, right? And what should be the correct procedure to do that? It should be through formula sheets, right? So in today's session, we'll be studying the whole engineering mechanics subject with the help of formula sheets. We'll be discussing each and every formulas, each and every concepts and relations, and those concepts which are actually very important from the GATE examination, and you will see directly some questions from these formulas and the concepts also, okay? So I hope you will enjoy the whole session. In complete 4 hours, we'll complete the subject of engineering mechanics for both mechanical and civil engineering, right? For both mechanical and civil. So first of all, we'll take a combined part of mechanical and civil. Then after that, we'll discuss mechanical part. Welcome Prashant Joy, Prashantjit Dev. Hi. Okay. So before starting the session, please guys do share the session to your friends so that they can have a quick revision of the whole subject in just 4 hours. Okay. We'll not do some numericals here. Whatever we are doing is just discussing the concepts, how to select the formulas. Actually, in engineering mechanics, most of the students have a doubt which formula is to be used for the numerical, right? Meenakshi, yes, good afternoon, a very good afternoon. So, in this session, we'll discuss the concepts and the formulas, right? So, overall, from this session, you will get a formula sheet, okay, that you can use for a revision purpose, okay? So, at this moment, you don't look after the notes, complete notes. Just look for the formulas and relations and directly solve the numericals, okay? So, I hope everyone has come. Please share the session, okay? We'll start the session, right? Okay. So the smart revision, the session name is what? The smart revision. We are having a smart revision, okay, through formulas and the concepts, right? Okay. So what are the topics that we are going to discuss? See, topics are what? Equilibrium, truss, friction, centroid, moment of inertia, right? Free vibration. And see, remember, this particular fifth topic is for the civil engineering branch, right? Just okay, this is for the civil engineering branch, right? Okay, specifically, but obviously mechanical people study this particular topic in theory of machine subject, but obviously the revision will be there for the mechanical also, right? Then we'll discuss the dynamics part. Okay, so from here you will see this part is for mechanical only. Okay, this part is for the mechanical person only, right? And this remaining 1 to 4, mechanical and civil combined, common syllabus I can say. So as you see, the previous year examination question from the truss, friction, equilibrium, centroid and moment of inertia, they have asked from all the topics, right? So when you are preparing the mechanics subject, actually it is a very basic subject. You should know the basics, but while solving some questions, you need some idea of the concepts and the formulas and the relation. Even if you just know the formula, you can solve many questions. So at last, in this last time, you should revise the formulas, revise the concepts, okay, and just directly solve the questions, right? So we'll start the session from the topic of equilibrium, right? We'll start the topic from the topic number 1, equilibrium, right? Now, see, this is equilibrium topic. So when we say equilibrium, right? When we say equilibrium, what does it mean? What does it mean? See, tell me fast. What does it mean from equilibrium? When we say word equilibrium in general, whenever we say term equilibrium, what does it mean? Actually, it means state of balance, right? It means what? State of balance. So state of balance of what? A body, whatever body you are considering for the analysis, for that body we are assuming a condition of balance. Balance condition we are assuming for that body, okay? Now, so as you all know, it is what? State of balance. Always remember, state of balance is this. Okay, we'll discuss the important relations that we are going to discuss. Golu, yes, correct. R, see, resultant equals to 0, correct, Golu, yes. But for the resultant equals to 0, see, this is not the only condition, there is also one more condition. Summation of moment equals to 0, right? Summation of moment equals to 0. That is also the one of the condition of equilibrium, right? So when we say state of balance, you need to understand what are the effects on the body. Actually, two effects are there. Always remember, there are two effects on the body. First effect is what? Translatory effects. Translatory effects, right? And second one is what? Rotational effect. So you have to balance both the effects, right? You have to balance both the effects. Okay, you have to balance both the effects. So for the translatory effects, Golu, you correctly said it is what? Resultant should be equals to 0. The resultant force should be equals to 0. But when we say rotational effect, there should not be any net moment present in the body. Why? Because if the net moment is present in the body, then definitely body will have a tendency of rotation. So always remember, when we say a balance condition, we don't want any tendency of a body. We don't want any tendency of rotation or any tendency of movement, or simply rotation is there. Let's suppose rotational are there, rotational effects is there. So basically what? Tendency of rotation is there, high per and high. Translatory effects, for the translatory effects, it should there should not be any kind of motion involved, right? Always remember, we have to balance both these effects, right? These are the effects that we need to balance. Now, when we are when we do analysis in engineering mechanics, we have two bodies. One is particle, another one is what? Rigid body. Okay, you have to consider both the bodies. First for the particle, then we have a rigid body, right? Now see, when we say particle, okay, always remember, when we say particle and when we say rigid body, both are important. You should know how to differentiate between particle and rigid body, right? So when we say particle, it means what? It is a body in which whole body is having a same motion. Vijay Agarwal, okay, thanks. So always remember, whenever you have a body, if it is having a whole complete motion, is same. See, let's suppose this is a body and it is moving like this with some velocity, right? Now, if I am saying the whole body is having a same motion, each and every particle is having a same motion, then the complete body itself can be called as what? Particle. Okay, always remember this particular thing. But if in some situations particles are having a different velocities, different displacements, right, different accelerations, then we cannot classify that particular body as a particle. So this is the most important differentiation between particle and rigid body. I hope this is clear. Now one more differentiation for the particle. For the particle, you will see concurrent force system. Okay, concurrent force system. And for the rigid body, you will see non-concurrent force system. Right? Always remember, this is very, very important. Concurrent force system you will see in case of particle only. You will not see any non-concurrent force system in particle, because it is not possible for a particle to have a non-concurrent force system. Right? Clear? This particular point is very important. Whenever you see concurrent force system, it means you can assume that particular body is particle. Always remember, either they will say particle, either they will say concurrent force system. So both are the same things, right? Always remember this thing. Now, see, when we say the particle, what are the conditions? Now, very important. What are the conditions of equilibrium? That is very important. Okay. Condition for equilibrium. Condition of equilibrium, right? And here also we have to see the condition of equilibrium. Right. So when we are talking about condition of equilibrium in particle, it is very obvious that as it is having a concurrent force system, so only a force will be acting. Only a force will be acting, right? How we can say that? See, when we say concurrent force system, right, what does it mean? All forces are acting at a point, at one point only. That is what? Point of application is same. Point of application is same, correct? Always remember, point of application is same. So it is a concurrent force system. So whenever you are having a concurrent force system, you will always have a one resultant force only. You will only have a one resultant force, right? Now let's suppose you are having a, let's suppose, a one resultant force like this. Okay, we want to see the condition of equilibrium, right? We want to see the condition of equilibrium. First we'll see the resultant force. Like, see, we can take a composition, or we can say we can resolve the forces along horizontal direction and along the vertical direction, right? Like this. So always remember, whenever the force system is given to you, the very best method to solve that particular force system is just to take the components along horizontal and components along vertical, right? This is very important. Any force system they have given, just take the horizontal components and the vertical components, right? If you do like this, then you can easily calculate what the resultant. How? See, for this force system, this will be the resultant, and what will be the formula? Summation of forces along x whole square plus summation of forces along vertical whole square, like this, correct? Like this will have the resultant force. Okay, so always remember, whenever they will give a force system or on any body, subjected to any body, you have to first calculate forces along horizontal and forces along vertical. Are you getting the point? Are you getting the point? Yes. So this is the formula by which we can calculate the resultant. Always remember this particular formula. Okay, we'll see a different methods of calculating resultant also. We'll see that. But now see, as we are talking about a condition of equilibrium, so only resultant will be there, one resultant force and no moment. But when we say for the equilibrium body, when we are talking about a rigid body, see, here two things are there. Rotational effects are also there and translatory effects are also there. Okay, because as in the particle only translatory effects are there, but in the rigid body rotation is also there. Okay, apart from the translation, both translation and we can say rotation is possible. There is no rotation in case of particle. Always remember, no rotation in case of particle, right? No rotation in case of particle. Always remember, right? Only translation. Only translation, right? This is very, very important. Now we'll write the condition of equilibrium, but before that you should always remember, particle means concurrent force system, right? Then for the concurrent force system, this is the way by which we can calculate resultant, and particle is only having what? Translation. No rotation for the particle, right? Always remember. Then for the rigid body, non-concurrent force system will be there. Okay, then what is the conditions of equilibrium? So for finding the condition of equilibrium, you need to understand what are the effects of non-concurrent force system, right? See, translation is one of the effect and rotation is another kind of effect. So you have to balance both the effect, right? You have to balance both the effects. Okay, now see, what are the conditions? Now we'll write the conditions. Okay, now we'll write the conditions. See, for a particle, okay, you have to use directly this equations. For the particle we'll write, then we'll write for the rigid body. Right, see, for the particle, what are the conditions? Tell me fast. What are the condition of equilibrium in case of particle? See, just for the particle, translation is there, so resultant should be 0. If resultant is 0, so obviously it will be 0 only when summation of force along x direction 0, summation of forces along y direction 0, right? So this is condition 1, this is condition number 2. Clear, guys? Now if we talk about rigid body, guys, tell me, two condition will remain same. First two condition are same exactly for the rigid body also, but what is the third condition? What is the third condition, guys? Tell me first. What will be the third condition in case of rigid body? Obviously we have discussed the particle. Two conditions are there, right? But what is the condition, third condition for the rigid body? Guys, tell me first. Yes, Golu Krishna, yes, summation of x and y we have written, it is 0. But what is the third condition? What is the third condition for rigid body? What is the third condition for the body? See, again, see very carefully. Translation and rotation is there. So you have to balance the rotation. For balancing the rotation, we need to have a moment equals to 0. Yes, correct. See, first condition is same. Summation of force 0 along horizontal. Then summation of force along vertical 0. Right. Then third, summation of moment equals to 0. Now, most of the people will be confused, sir, where we have to take the moment equals to 0. Where we have to take the moment equals to 0. Where we have to take the moment equals to 0. See, when you have considered the whole body under equilibrium condition, then you can take moment equals to 0. Summation of moment equals to 0 at any point. At any point, right? On the body, you can take any point. Why? Because you have considered the whole body under equilibrium condition. Clear? So for that, you can consider the moment about any point. About any point. So these are the conditions that you need to understand. Okay. So whenever, okay, Deepak, a very good afternoon, Deepak. Very good afternoon. So remember this particular point. For particle, these are the conditions. For the rigid body, these are the conditions. So when we have to use this condition, see, in the question, first of all, you have to understand whether the given system is acting as a particle or rigid body. Whether the given system is acting as a particle or rigid body, right? So first you have to differentiate between particle and rigid body. Then see whether the given system is in equilibrium. If it is confirmed that it is an equilibrium condition, then you can use equilibrium equations. If it is rigid body, these are the equations, and if it is particle, these are the equations. So first of all, you have to confirm whether particle or rigid body, then check the equilibrium. If it is equilibrium, then you can use the equilibrium equations. Right? I hope up to this point everything is clear. So always remember this condition. Okay. So many times the gate has asked from the equilibrium topic. Right? Now, what are the important questions are there which are gate has already asked? We will also see that. We'll also see. Okay. Now see. One of the most important thing for calculating resultant. See, we'll see different cases in which we calculate the resultant force. Now see. If there is two forces are acting like this, F1 and F2, right, on this particular point O. So to calculate the resultant, there is a very simple formula. I hope everybody knows, right? Everybody knows about this particular formula. See, this formula is not important in engineering mechanics, but also in other subject also, because these are vector quantities. You can assume any other vector. It is not necessary that you have to take force only. You can take another vector also. You can take the different velocities also. In place of forces, you can take velocities also. You can take different parameters. But to calculate the resultant of two vectors, basically force are nothing but the vector only. Okay, these are the nothing but the vectors only, right? So to calculate the resultant of two forces or two vectors, basically, we will be using this particular formula, right? Plus 2 F1 F2 cos theta, right? Always remember this particular point. See, this is a very simple formula, but you have to understand one more important point. See, what is the maximum R that can be possible? What can be the maximum R that can be possible? See, theta is what? Angle between the two vectors. I am taking forces as a vector, right? You can even take the velocity also. Okay, you can even take the velocity also. Now see. See, these are the two vectors. For two vectors, this is the resultant formula. What is the maximum possible resultant, guys? Tell me fast. What is the resultant? Maximum resultant. What will be the maximum resultant? This is the formula for the resultant. But what is the maximum resultant that these forces can have? Maximum value of resultant. See, you are taking, you are saying 0. Actually, you are saying the theta equals to 0, right? Golu, correct? You are saying theta should be equals to 0, right? So if theta equals to 0, you will be getting what? F1 plus F2, right? Now, what is the R minimum? See, what is the R minimum we will have? If theta equals to 180 degree, theta equals to 180 degree. Abhishek, 0 and 180, yes, absolutely correct. 0 and 180. So for the 180 degree, we'll have F1 minus F2. Now, very important point here. Your resultant value will lie between, always remember, your resultant value will always lie between R minimum and R max, right? This is very important, right? This is very important. The resultant value will lie between R minimum and R max. R minimum and R max you already know. These are the F1 plus F2, F1 minus F2, right? Okay, this is very important. Now another concept in equilibrium is what? The Lami's theorem. You remember the Lami's theorem? And for applying the Lami's theorem, we should know what are the conditions under which that particular theorem can be applied. Okay. Deepak, for 90 degree, if you take the 90 degree, definitely it will have some R value, but it will lie between this range. That particular value, if you take theta equals to 90 degree, if it will become under root F1 square plus F2 square, it will become 0, right? So that value will lie between this range. Okay. All the values of resultant will lie between this range only. Okay. Remember this particular point. Right. Now, second thing that we need to discuss is, okay, second thing. Now, about the Lami's theorem. See, you will find the application of Lami's theorem in many of the questions. Even GATE has asked many questions from this theorem only. Actually, they will not mention we can use Lami's theorem. It is our understanding that yes, under the given circumstances, whatever they have given, for that we can use Lami's theorem. But what are those conditions? First of all, we need to understand what are those conditions under which we can use Lami's theorem. See, any body, okay, any body subjected to three forces, right? Subjected to three forces, right? First of all, any body subjected to three forces, okay, and body is under equilibrium condition, right? 2 points, always remember. Body subjected to three forces, right? Only three forces, right? And second, body is in equilibrium condition. And body is in equilibrium condition. Yes, acting on a point, or even we can say on a body, or we can even say on a body. Same line of action? No. It is not required that all have a same line of action. No, it is not required. Only point that we need to understand here is that body subjected to three forces. Body subjected to three forces, body is in equilibrium condition, right? Yes, particle in equilibrium. Yes, absolutely. It is the conclusion point. I am coming on that. See, body subjected to three forces, body in equilibrium. Then we can say all the three forces will be what? Concurrent. All the forces will be what? Concurrent. And if the forces are concurrent, we can assume that body is a particle, right? See, these 2 points are there. Okay, they have given a situation in which a body is subjected to three forces. We don't know whether they are concurrent or non-concurrent. We don't know, first of all, because it is not mentioned in the question. It is concurrent, non-concurrent. They didn't mention about that. They just mention body subjected to three forces. Okay, then they have said it is equilibrium. Now, if these 2 points are confirmed, then we can say three forces are concurrent. Three forces are concurrent, right? Then we can say three forces are concurrent. Okay, always remember, body subjected to three forces and it is in equilibrium, then the three forces must be concurrent. Okay, must be concurrent. I will replace this R with must be concurrent. Must be concurrent, right? Always remember, always, very, very, very important. Three forces must be concurrent. Now, how to use this Lami's theorem? How to use? See. Actually, this Lami's theorem is nothing but the sine law. We'll also discuss the sine law and cosine law, or we can say rule, because it will help you not only in engineering mechanics, also in other subjects. Okay, in your other subject, it will also help you. So let's suppose this is F1, this is F2, this is F3, like this, right? Now, F1 opposite to F1 angle, it is alpha. F2 opposite angle is beta, and F3 opposite angle is gamma. So you will write, see how you will write, F1 divided by sine alpha, F1 angle which is opposite to F1. So angle opposite to F1 will be what? Angle between F2 and F3, that is what? Alpha. Okay, in the similar manner we will write F2 divided by sine beta and F3 divided by sine gamma, right? F2 opposite angle will be beta and F3 opposite angle will be gamma. So you will be using this particular relation. Okay, you will be using this particular relation, but what are the conditions? These are the conditions, right? These are the conditions. In the GATE examination, you will find an application of this theorem also, right? Any doubt, any confusion up to this point? Any confusion? Any confusions, guys? Any confusions or any doubts? Okay, clear, all clear. Okay, great. Now we'll see the sine law and the cosine law. Okay, it is another basic point that we need to understand, right? Okay, we'll write it here only. See, we'll use the sine law and cosine law. Just 1 second. Okay, just 1 second. Okay. See, you have written this particular thing. If you have written this particular thing, then we'll do one thing. Just 1 minute. Just 1 minute. We'll add one more slide here. Actually, we'll put one more slide here. Yes, now it's okay. Yes. See, I'm talking about this particular thing, right? Sine law and cosine law, or we can say sine rule or cosine rule. See, if you have a triangle like this, let's suppose this side is A, this side is B, this side is C. Please be careful about this particular rule. It will help you in engineering mechanics in your other subject also. Okay, in your other subject it will help you out. Okay, it will help you out in other subjects also, right? Many times we are confused how to solve a question. We'll stuck in some calculation part. So in those scenarios, sine rule and cosine rule will help you. Okay. Another thing that we need to discuss is what? Cosine rule. Very, very important. Now see, opposite to A angle is alpha, opposite to B angle beta I am assuming, and opposite to C angle gamma I am assuming. Now what is sine rule? See, what is sine rule? A divided by sine alpha. Opposite to A, what is angle? Alpha. B divided by sine. Angle opposite to B is beta. C divided by sine. Opposite to C angle is gamma. Right? ABC can be any parameter. Right? ABC can be any parameter. Right? It might be force, it might be velocity, it might be anything. Okay. So these ABC are nothing but the different parameters. Okay. That will depend upon the situations. If these ABC are the parameters which are forming a triangle, then you can use this particular relation from the trigonometry, sine rule. But what is cosine rule? See, A square equals to, see, if we are talking about A square equals to B square plus C square minus 2BC, and opposite to A, what is angle? Cos alpha. This is also important. These relations will help you out in some numericals. Okay, not necessarily it will help you in engineering mechanics, but also in other subjects also, right? Then we'll write for b square. Apart from b, what are the two sides, a and c? So we'll write like this. What is the angle opposite to b? That is beta. So we'll write cos beta. Then finally we'll write for c. Apart from c, what are the two sides, a and b? A square plus b square minus 2ab cos gamma. Okay, please write down these particular formulas in your notebook. It is very important. Please write it down in your notebook. Okay, note it down, all these particular formulas, guys, fast. All these formulas are very important. Right? Done. So up to this point everything is clear, guys. Tell me first. So we have discussed the equilibrium chapter. Okay, important points from the equilibrium chapter we have discussed, right? Clear, guys? This is clear up to this point, everything, guys. Tell me first. Now we'll move on to the next topic of, basically we can say, next chapter, that is truss. Again, very important and very scoring part. In the engineering mechanics, truss is the only part which is very scoring, which is very scoring part. Okay, now move to the next part, truss. Okay, in truss part you have to understand what, first of all, a very important concept, that is zero force member. Zero force member. Okay Deepak, great, go look, great. You need to understand the zero force member concept. You need to understand the method of joint. You need to understand method of section. Okay, and you need to understand how to differentiate between whether member is in tension or compression. Okay, Subodh, clear. Now see, first of all, first topic in the truss is zero force member. Okay, in any question of a truss you need to understand whether some members are zero force members. You have to understand this particular concept, right? Because if you use this concept, your analysis will become what, simple. आपका जो analysis होने वाला है, it will be what, simple, right? So always remember, whenever truss question is there in front of you, always think of zero force member. So whenever truss diagram you will see na, immediately in your mind zero force member concept should strike. एकदम ट्रस का क्वेश्चन दिखते ही आपके माइंड में जीरो फोर्स मेंबर के कंसेप्ट आ जाने चाहिए. क्यों आने चाहिए, उसका रीजन ये, with the help of this concept your analysis of a truss will become very easy. Otherwise you will find it very difficult to solve some questions of a truss, right, if you don't understand the concept of zero force member. Right, now understand. So first, there are only 2 points in the zero force member. Only 2 points in the zero force member. First point, if only 2 non-collinear members, please understand this point, 2 non-collinear members form a truss joint. Okay, from a truss joint, right? See, this is a joint in which 2 members are there, which is what, non-collinear, okay? And important thing, please highlight this part, external load or support reaction. Okay, no external load or support reaction is applied to the joint. See, this joint is not having any support, no support and no load is acting at the joint, right? Clear? No support is acting and no load is acting on this particular joint. So it is free from support reaction. First of all, it is free from support reaction. Second, it is free from any load. Now, if this is a scenario in the truss, you can directly say, let's suppose this is member 1, this is member 2. You can directly say the force in member 1, force in member 2 equals to 0. Actually, they are nothing but zero force member. Please always remember, in a truss you find out this particular scenario, you can directly say these are zero force member. But always remember the condition, because many times students forget about the conditions. They will always remember the main point, but they forget about the conditions. Please don't forget about the conditions. Conditions are very much important, because this point is applied or applicable only when these conditions are valid. Okay, what is the condition? No support reaction at the joint, no load at the joint. Simple. So these are nothing but the zero force member, right? Clear? Okay guys, clear everything? Now, second point for the zero force member. Second point for the zero force member. Always remember, I have said a non-collinear member, right? Definitely it is having some angle. If it is collinear, then the forces are equal. Remember, joint having two members only. Joint having two members only, and they are what? Non-collinear. If they are collinear, then forces in both the members will be equal, right? Now, see, second point in the zero force member. Second point in the zero force member. See, if three members form a truss joint, okay, great Deepak. If three members form a truss joint, now here three members we have taken, previously we are talking about the two members only, right? See, previously we have talked about the two non-collinear members, okay? This is a truss actually. Right? So previously two non-collinear member, here three members are there. Now, three members form a truss joint which two of the members are collinear. Now again, very important. Two members are collinear. They have mentioned two of the members are collinear. See, this is the joint. Let's suppose this member 1, this member has 2, this member has 3. Right? This member has 1, this member has 2, this member has 3. Correct? Now, see, 1 and 2 are collinear. So this is the first condition. First condition, these two members are collinear, right? Then the third member is a zero force member. So always remember this particular point. Joint having three members, 1, 2, 3, in which two are collinear. Then automatically, then third member will be zero force member. Automatically, third member will be what? Zero force member. Clear, guys? Again, the condition is same. No support reaction at the joint, no load at the joint. Right? So, from here we can say force in member F3 will be what? 0. Force in member F3 will be what? 0. And it is what? Collinear. So, definitely F1 equals to F2. Right? We can say like this. Guys, tell me, this particular point is clear? Concept of zero force member is clear? It is clear to everybody? Guys, tell me fast. If it is clear, then we'll move on to the next topic of method of joint and method of section. Those methods are very important for the analysis. Okay. Whenever the analysis question will come, like they will ask a force in some member, then you will use method of joint or method of section. Right? Okay. Clear? Great, Golu. Next. Okay, before going to the method of joint or method of section, first of all, we should know how to differentiate between tension member and compression member. You should know how to differentiate between both the tension or compression member. Okay. Now, here you need to understand a very important concept here. How we will decide whether it is in tension or compression. Okay. Right. See. Let's suppose there is a member. This is your member, and let's suppose this is your joint. Okay, this is your joint. Actually, joint member will be connected to the joints. Right? But I place the member apart away from the joints. Okay, so that I can show the force. That's why I place the joints apart from this member. Right? So otherwise, how the diagram will be what? Diagram will be like this. Diagram will be like this only. Here the joints will be there. But actually I put this joint here. So that I can easily visualize the force direction. Okay. That's why I've make the member and joint separately. I've drawn the joints and members separately. Right? That's why. Now, see. Now, all the analysis in the truss we are doing on the joint. Okay, always focus on the joint. You need to focus on the joint, right? Now, if the force is acting towards the joint, see, if the force is acting towards the joint, carefully observe, force acting towards the joint, right? If the force acting towards the joint, so as we said, truss is a structure and we need to have an equilibrium condition for the truss, okay, because it is a structure, so equilibrium conditions are applicable on the truss. So when we say equilibrium conditions are applicable on the truss part, each and every part of the truss will be under equilibrium. Each and every part of the truss will be what? Equilibrium only, right? So if there is equilibrium, right, if there is equilibrium and we are saying joint is having a force like this, on the member, how the force will be? How the force will act? On the member, how the force will act? See, it will act like this. It will act like this, right? Because if there is a scenario, then we can say both will be cancelled out, and system will be in what? Equilibrium. System will be what? In equilibrium, right? This is clear? No, it will not be tension, Deepak. It will not be in tension. See, it will be in compression. Member will not be in tension. It will be in compression only. Clear? Deepak, it is clear to you? It is in compression. See, member is in compression, not in tension. Any doubts? Any doubt? Any confusion? Yes, compression, Golu. Yes, absolutely correct. Okay, so you need to focus on what? Joints. See the joint. See the joints. Okay. So we can write a point here that whenever force acting towards the joint, member will be in under compression. Okay. See, we'll write it like this: when force towards the joint, then member will be under compression. Clear? Okay, great. Clear? Deepak, clear na? Okay, great. So you need to focus on the joint, right? Forget about the members. Always focus on the joint, right? Please remember in such a way that there will not be any confusions, right? Most of the time students feel the confusions in deciding whether tension or compression. Okay, so there will not be any confusion when you focus on one thing, right? So you just need to focus on the joints, right? So if the force is acting towards the joint, member will be in compression. Now we'll see the second part. See, now let's suppose this is the joint. Now see, now if the force is acting away from the joint, now clearly observe this thing, force acting away from the joint. If it is acting away from the joint, for the equilibrium condition, force on the member will be what? Like this. Force on the member will be like this. Now we can say force will be cancelled out. And it will be in equilibrium condition. It will be in what? Equilibrium condition, guys. Clear? So now the member will be in what? Tension. Member will be in what condition? Tension condition, right? So we'll write a point here. When force is away from the joint, then the member is in tension, right? Now, yes, Deepak, correct, tension. So now there will not be any confusions in deciding whether member is in tension or compression. Okay, now up to this point I think everything is clear. So always remember how to decide tension or compression. This is the way by which we can decide tension or compression, right? Clear? So towards the joint, compression, right? Away from the joint, tension. Just remember this particular point. Okay, there will not be any confusions after this. Okay, great. Now see, method of joint. See, you need to understand some important steps or the procedures. Okay, you need to understand some procedure. Okay, there is some procedure by which we can solve the truss from the method of joint. So we need to understand the steps. So write down the steps actually. What are the steps that we need to use for solving method of joint? The question from method of a joint, right? Question from the method of joint. See, first step is what? To find the support reaction. Find support reaction. And how you can find out support reaction? By using equilibrium conditions, right? By using equilibrium conditions. Okay, let's suppose this is the truss. Okay, let's suppose this is the truss. Okay, this is the truss, and you are analyzing the truss. That is basically you are calculating the force on each and every member. Okay, so first of all you need to calculate what? The support reactions, right? See, this is the hinge support, this is the roller support. You know, a support reaction will be acting like this, support reaction will be acting like this. But important point here is that this is hinge, this is roller. This is hinge, this is roller. So if there is any horizontal force is acting, then there is one more reaction at the horizontal. One more reaction at horizontal level. Okay, because this is hinge. So horizontal reaction will be there, but it depends whether the horizontal force are present in the system or not. Right? Remember this thing. Okay. But on the roller support, there will be only vertical reaction, no horizontal reaction. Step number 1 clear. Find the support reaction by equilibrium equations. By equilibrium equation. By using equilibrium equation, right? Second point. After calculating the support reaction, select that particular joint which is having maximum 2 unknown. Okay, select that joint for analysis. Select the joint for analysis. Okay, select the joint for analysis, right? Which is having unknowns not more than 2. Which is having unknowns, which is having unknown force, not more than 2. Not more than 2. See, but why we have written like this? Only 2 unknown. But why, Deepak? Why? Why there is a need that we need to select that joint only in which there are 2 unknowns? Max to max 2 unknowns are there. If let's suppose 3 unknowns are there, we are not able to calculate it. But why? Any specific reason behind that? Any specific reason, guys? Tell me fast. Any specific reason? Any specific reason, guys? Tell me first. Any specific reason, Deepak? Any specific? Why we are saying like this? Ki not more than 2. See, moment equals to 0 not applicable. Meenakshi, yes, exactly. But it is not applicable because we are analyzing a joint, and joint is having a concurrent force system. Harshvardhan, we can use the Lami's theorem when 2 unknowns. Yes, yes, correct. Now see why we have said, okay, not more than 2, right? And see, next we'll write here. See why we are saying. So let's suppose select any joint. See, we have drawn the truss here, na? Right? So let's suppose this is a joint A. Take any joint, okay? Take any joint. Let's suppose joint A I am talking about. Joint A I am talking about, right? So joint A, this member is there. There is another member. This is the vertical reaction, right? So let's suppose member 1, member 2. So we are doing a joint analysis. We are doing joint analysis. And if we are doing a joint analysis, then we are having a concurrent force system. We are having a concurrent force system. And if we are a concurrent force, if we are having a concurrent force system, then 2 equilibrium equations are available, right? Only 2 equilibrium equations are available. Right? Because we are doing a joint analysis, all the forces are acting at a point. That's why we have said that we have said what? The concurrent force system. Okay, then only we have said, na, it is a what? Concurrent force system. So all the points, all the forces are acting at a point. That's why it is a concurrent. And if it is a concurrent, 2 equations are available. So max, at max, 2 unknowns can be solved by using method of joint. Only 2 unknowns can be solved by using method of joint, by considering one joint, right? Yes, 2 equations. Yes, exactly. 2 equations ही है हमारे पास. बिल्कुल exact. Correct, Deepak. Now see, this is a method of joint. This step you need to understand. First, support direction, calculate support direction, then select a joint which is having a max 2 unknowns. Then solve, okay, by using this equations, right? Now, method of joint is actually a little bit time taking process, okay? It is time consuming process. If you solve any question by using method of joint, it will take a long time. Why? It is what, why I am saying it is taking so much time? Because you need to select, let's suppose I am talking about this member. I need to calculate on this member. Let's suppose member A is there, right? Let's suppose member B. I'm calling it as a member B. I have to calculate the force on B. So for calculating the force on member B, I have to calculate, first analyze joint A, then this joint, then this particular member I can find out. Okay, then only I can find out the force on this member. So I need to solve 2 joints. I have to do analysis for the 2 joints. Then only I can get the value of force on member B. So it is taking so much time. Okay, first you will do analysis for first joint by this, using this equation. Then again you have to use this equation for another joint. Then you will get the answer. So it is actually very time taking process. But here is the solution for we have. Here we have a solution. What? The method of section. Method of a section is one of the best way to solve truss, okay, and very easy method. Okay. From the if I compare from the method of joint, method of section is actually easy, but most of the people will find it very difficult. Why? Because in method of section you need to think about which equation you need to use, okay, which equation you need to use. Because in the method of section we will have 3 equations. How we are having 3 equations? See. So first of all, tell me this method of joint is clear? This method of joint is clear? Now we'll talk about method of section. We'll talk about method of section. See, let's suppose again I am taking a truss here. From example I will see how we can solve the truss problem with the help of method of section. Right, this is our truss. Now to calculate the force on any other member, here we are using the method of section, right? But in method of section, what we are doing? We are not doing any joint analysis. First, we are doing what? We'll cut the truss through a section. We'll cut the truss through a section. Okay, in method of section, we'll cut the truss through section. Now, you can cut the truss in any way. Let's suppose this is a section by which I am cutting the truss. Now, actually, you need to cut the truss. Okay. Yes, absolutely correct, दीपक. दोनों से सेम आंसर आने वाला है. Yes, absolutely. बट हमें वो अप्रोच, वो मेथड सिलेक्ट करना है जिससे हमारा आंसर बहुत इजीली आए एंड कम टाइम में आए. आप क्वेश्चन सॉल्व कर रहे हो तो आपको टाइम मैनेजमेंट का भी ध्यान रखना है, राइट? You need to take care about the time also, right? Okay, let's suppose if I solve the question from method of joint, it is taking 2 minutes, but if I use the method of section, it takes only 30 seconds. So which one is better? Method of section is better, na? So that's why always focus on the method of section part, right? So cut the truss through section, right? So let's suppose they are asking the force. See, let's suppose they are asking the force on this member. Let's suppose this member I am saying P member. Okay. So wherever they are asking the force, right? Wherever they are asking the force, cut the section through that member. Cut the section through that member. So basically your section should pass through that particular member in which they are asking the force, right? Right? Clear? So let's suppose they are asking the force in member P. So I have cut the P member through this section. Okay, I have drawn the section, right? This excess section I have drawn in such a way that it will pass through the member P. Okay. Now, if it has cut the truss, now I will draw both the cut truss. Okay, whatever the cut truss is there, I will draw. Right. See. Okay. Here I will draw like this. See, this is the left part of the truss. Okay. See, this XX section has cut the truss in two parts. This section XX has cut the truss in two parts. This is the left part. Now I am drawing the right part. Now, guys, tell me, it is clear? The left part and the right part. So you need to cut the truss through a section in such a way that that section should pass through a member in which they have asked the force. So always draw your section through that member in which they have asked about the force, right? So in P member they have asked, so I have drawn the section in such a way that it has passed through P. So we are having a two cut truss, left part and the right part. So as in the starting also we have discussed that we are assuming entire truss in what? We are assuming the entire truss in what? Equilibrium condition. Amrita, good afternoon, a very good afternoon. So we are assuming entire truss to be in equilibrium condition, right? Now see, if you have cut the truss, so left part, right part should also be in equilibrium condition, right? It should also be in equilibrium condition because you are considering the whole truss under equilibrium. Now, if you have cut the truss in two parts, so every part of a truss should also be in equilibrium condition. Okay, this point is very important. Now, it is up to you whether you are taking left part for the analysis or right part for the analysis. It is totally up to you, right? It is totally up to you. Now, see, I need to calculate force on P. I need to calculate the force on P. See, this is P member. This is P member. Can anybody tell me how we can calculate the force on member P by using just only one equation? Guys, tell me fast. So I am putting the names of the joints here. I am putting the names of the joints, right? See, this is joint 1, let's suppose. Joint 2, 3, 4, 5, 6, right? Joint 1, 2, 3, 4, 5, 6. Now, can anybody tell me how we can solve for the P by using just only one equation? In just one equation, summation of moment 0, but about which point? Gautam has said about point 3. Yes, absolutely correct, absolutely. By using just only one equation, we can calculate the value of force P. How? Just take the moment about point 3. Why? See, when you analyze the left part, na, this is also unknown. Let's suppose this is some unknown. This is also unknown. This is also unknown, right? Unknown. UK basically means unknown, right? Okay. UK basically means unknown. This is also unknown, right? In place of UK, I just put the different names. Otherwise, it will confuse you. So, let's suppose this is member Q. This is member R. So, actually, Deepak, you are saying what? Horizontal? No. We cannot take the horizontal. Let's suppose, Deepak, you are taking the horizontal. Na? So, Q component will also act in the horizontal. But Q we don't know. So, two unknowns will be there in one equation. So, always remember, our objective should be such that the quotient should be solved in one equation only. Quotient should be solved in one equation only, right? Right? Always remember this particular thing. If you take horizontal, na, so P is also already unknown, Q is already unknown. So, two unknown, one equation, we cannot solve it, right? So, what we do, we'll take a moment about point 3. If we take a moment about point 3, then see, Q is passing through 3, Q is passing through 3, R is passing through 3. So, Q and R, moment about 3 will be what? 0 automatically. Moment of Q about 3 and moment of R about 0.3 is automatically 0. So, we don't need to calculate it. Only P will be the unknown. Only P will be the unknown, right? So, by using this particular equation, you can calculate the value of what? P directly. In only one equation, you can solve the value of P. So, this is the way by which we can solve the question through method of section, right? So, see, method of section is very easy. Just you need to practice some 1 or 2 questions, okay? And you need to draw, you should need to understand how to draw the cut sections, left, right, where to take moments. Hridesh, a very good afternoon, Hridesh, right? So, I hope this is very clear to you. Let's suppose I want to calculate Q. Again, one more question, guys, please understand here. Let's suppose you want to calculate the force on Q member by using only one equation. Can you tell me which equation will be used for calculating Q? Remember, we want to calculate the force in member Q by using only one equation. Which equation I can use? Which equation should be used, guys, to calculate Q? Only one equation, guys, only one equation, tell me. Moment equals to 0. But where? Summation fx equals to 0. If you take summation fx 0, P is the value unknown. Deepak, vertically. Yes. Array, Q has a vertical component, but P and R, the horizontal ones, it will not come in the vertical equation. Sum of the vertical equals to 0. Yes, correct, Meenakshi. Correct. Golu, correct. Gautam, correct. Yes, correct. Hridesh, if you take the moment about 0.8, so definitely, see, P will be there. Only R will not be there, but P and Q both are there, and P and Q both are unknowns, right? So actually we need to solve the unknown value in such a way that it should be solved in one equation only. It should be solved in one equation only, right? We don't need to calculate another unknown also, right? So for calculating q, we'll use what? Summation fx, summation fy equals to 0. Then we'll get what? Q value, right? This is clear. And if we talk about r, and if we talk about r, and if we talk about r, if we want to calculate r value, which equation should be used? Moment about point 2. Yes, Meenakshi, correct. Absolutely. Because if you take the moment about 2, P and Q both are passing through 2 only. So obviously P and Q will be 0. We don't need to calculate P and Q. If we take moment about point 2, then only R is the unknown. Why? Because P and Q is automatically 0 when we take moment about point 2. It is clear to everybody, guys? It is clear? Yes or no? It is clear, everybody? Okay. So see, method of section is very easy method. Just you need to practice 1 or 2 questions, right? If you solve the previous year question through, try to solve all previous year question through method of section, right? It is the best way to practice. Just solve all previous year question through method of section only, right? Yes, Deepak, yes, Gautam, we have to take the moment about 2 for calculating R. Right? Clear? Okay. We'll move on to the next part. Okay. Okay. One more important topic. Not an important topic, but an important concept, we can say. It will help you in simplifying your quotient part. Interest. Pair of two collinear members. See, let's suppose this is your joint. One member is like this, another member is like this. Right? Like this. So let's suppose member 1, member 2, member 3 and member 4. Understand? 1, 2, 3. Now, as we know, 1 and 2 are collinear pair, 3 and 4 are collinear pair. So if there is a situation like this in a truss, so we can directly say F1 equals to F2 and F3 equals to F4. Directly we can say without any calculation, right? Collinear pairs will have a equal force, right? Yes, Sonu Thakur, exactly. 3 and 4 will have a same force. Let's suppose in place of 3 there is a one force is there, right? Let's suppose they can also give like this. See, there is a joint like this. Some load is acting like this. Let's suppose joint P load is acting like this and there is a one member. Okay. Now see, this is member 1, this is member 2, this is member 3. Okay. So this joint is having what? This joint is having 3 members. And load P is acting on the joint. Now you remember the zero force member concept number 2, in which we have said 2 members are collinear, third member will automatically become what? Zero force member. Now here we can say member 3 is what? Zero force member. Can we say like this? Member 3 is what? Zero force member. Yes or no? Member 3 is having a zero force. Correct? Yes or no? Can we say like this? 2 members are collinear, third member will become automatically zero force member. Yes or no? Correct? Sonu Thakur, no. Yes, Sonu, correct. Gautam, no. We cannot say F3 equals to 0. How we can say F3 is 0? You forget about the condition. There should not be any force or any support reaction on the joint. See, there is another scenario like this. In this particular case, you can say F3 is 0. But here you cannot say F3 equals to 0. In this case, you can say F3 0, but here you cannot say F3 0. Why? Because load is acting on the joint. Always remember the conditions, guys. No load and no support reaction on the joint. Then only the zero force concept will be valid. Right? Clear? Okay, great. But here important point is that F1 will equals to what? F2, obviously, because both are collinear, but force on member 3 equals to force P. Why? Yes, Deepak, correct. But why? Because 3 and P force are what? In the collinear, in the same direction. The line of action of force P and this member is same. If the line of action is same, then we can say it is collinear. And if it is collinear, so definitely force in member 3 will be what? P. We can say like this. So this concept is very important, guys. In some trust question, directly you can calculate F3 equals to P. If you don't know this concept, if you are doing what? Calculation, unnecessary calculation you will be doing. So by this concept, a lot of calculation part will be saved if you know this, just these points, right? Just note it down, these points, guys, fast. Note it down. Note all these points. Okay. Clear, guys? Now. Okay, this concept is also important while doing the truss analysis, right? Now, we'll move to the next part, that is next chapter, friction. Friction, right? Okay, friction. See, always remember whenever we are talking about friction, remember one important point. When friction will come into the picture? When will friction force will come into the picture? Tell me. When the force of friction will come into the picture? There is any condition? Is there any condition? Yes or no? See, this is the point you need to understand. Clear? When an external force is applied, but important part is that which causes the relative tendency of motion. Correct, absolutely correct, Sonu. Absolutely. Then the frictional force starts developing. Okay. If there is a tendency of relative motion, then only we can say the friction force will start developing. Okay. Yes, Deepak, correct, absolutely. Okay. So remember this particular point, very, very important. Okay. See how we can understand this point. Consider this example, right? This is a block. Okay. Can we say there is friction acting on this block? Can we say like this? Can we say yes or no? No, in this case, will not say the friction force is acting. Why? Because no tendency of motion. Yes, absolutely correct, Sonu. No tendency of motion. But now, if I apply the force, no matter how much amount of force you are applying, it doesn't matter at all. It doesn't matter at all how much amount of force you are applying. What is the magnitude of force P? Doesn't matter. Why? See, you just need to understand whether this force is creating any tendency of motion. Yes, this force is creating tendency of motion. Where? Towards right. Okay, towards right. This is the tendency of motion. So always in case of friction, we need to check what tendency of motion. We need to check tendency of motion. Yes, tendency of motion will be like this. Okay. So if there is a tendency of motion, then friction force will start. Then friction force will start developing on the body. And how it will act? It will just act in such a way that it will oppose the motion of the body. It will oppose the motion of the body, right? This is very important. Okay. So frictional force always tries to oppose the relative tendency of motion. And most important point, see, whenever the contact is there, see, block, this is your block, okay, this is the horizontal floor. So you need to check the relative motion. How you can check the relative motion? Let's suppose you need to check the relative motion of block. So from another surface, you have to see the block. Now you are observing the block from the horizontal plane. Now you are observing the block from the horizontal plane, right? Then you can say, what is the relative tendency of this block? Yes, towards right it is moving. Now you need to check the relative tendency of motion of this plane. How you can check? See, for that you need to observe the plane. Now you need to observe the plane by standing on the block. Let's suppose you are standing on the block, then you need to observe the plane. Okay. So whenever you need to check the relative tendency of motion, just be there on the another contacting surface. Whenever the contact is there, two bodies are participating on the, whenever contact is there, two bodies are participating, right? So always stand on another body and observe other body. So if I want to check the motion of block, I will be here. Now if I want to check the motion of this plane, I will be here and observing the plane. By this way, we will be checking the relative tendency of motion, right? This method is very important, guys, because in upcoming examples, right, in the case of wedge friction, it is very important to understand the direction of friction. In some cases, we will be still confused about the direction of friction. Here it is very easy to say where is the direction of friction. It is very easy. But in case of wedge friction, where a lot of frictional forces are involved, then in those cases, the confusions will be there. But you will not find any confusions if you know this concept. For checking the relative tendency of motion, check the motion of a body by looking from another body. For this block, I will be here. For this plane, I will be here and observing the plane. Clear? Now, I hope this is clear. Now see, three cases are possible. Thank you, Mayank. Thank you. Three cases are possible here. See, when this block is there, let's suppose this is the block, okay, right, and it is subjected to a force like this, P. Now definitely frictional force will act, okay, frictional force will act like this, right, and the normal reaction will be like this, right, and obviously some weight is also there. Okay. Now three conditions are possible, right? What are those conditions? See, first condition, if P value is less than the frictional force value, but we are considering the maximum frictional force value. See, obviously we are saying this frictional force is opposing the relative tendency of motion of a block, but there is some limit up to which it can act. Yes or no? There is a maximum limit for the frictional force, right? There will be some frictional maximum limit on the frictional force. What is that maximum limit? Maximum frictional force. Let's suppose I am considering that maximum value as maximum frictional force, and I am representing like this. Okay, clear? So obviously frictional force starts developing from zero value, but it will go up to the maximum limit, and after that limit it will not increase further, right? When we say frictional force starts developing, right, so it will start from zero, absolutely correct, but it will go up to the maximum limit, and after that it will not go further. Okay, this is very important. So I am assuming, let's suppose maximum frictional force is acting, or let's suppose it is not acting, just I am assuming this, there is one maximum frictional force, right? Now if P value is less than maximum frictional force, what will be there? we can say no motion will be there, right? This is the first possibility that we are having. This is the first possibility, right? Now, second possibility. What is the second possibility? P value equals to maximum frictional force. P value equals to maximum frictional force. Correct? P value equals to maximum frictional force. Under this condition also, body is not moving. Under this condition also, body is not moving, but it is just about to move or just about to slide. Okay? In this situation, body will be just about to move or just about to slide. So, if little bit P value will increase, definitely motion will start. Okay? So, such type of condition is known as impending motion. Impending motion condition. Right? And the third case, the third final case, if P value is greater than maximum frictional force value, then we can say body is under motion. Is under motion. Right, guys, tell me, this particular point is clear? This particular point is clear to everybody? So, frictional force will start developing from a zero value, it will go up to the maximum value. Okay, we are comparing the value of P with the maximum frictional force value. If our P value is less than maximum frictional force value, no motion will be there. No motion will be there basically means static condition. Static, right? Now, let's suppose our P value is equal to the maximum frictional force value, right? So, under this condition also, static condition is also there. Under this condition, body is in static condition. But a very important name for this condition is what? Impending motion condition, right? It is known as impending motion condition, right? This is the important point. Because this point you will see in many of the questions, impending motion condition. So, always remember whenever in the question they mention just about to move or just about to slide or they mention impending motion condition, it means that maximum frictional force is acting on the body. Maximum frictional force is acting on the body, right? Always remember this particular point. They will not directly say in the question that maximum frictional force is acting. They will not say like this. They will mention that body is under impending motion condition. They will mention just this. They will mention just this point only. Okay, this point only they will mention. So, from this point we will interpret that maximum frictional force is acting, right? And if P value is greater than maximum frictional force, body is under motion. And what does it mean? It means that dynamic condition, right? It means the dynamic condition. It means what? Dynamic condition. Clear, guys? I hope this particular point is clear. So, it is under dynamic condition, right? So, starting the frictional force will start from zero only, but it will go up to maximum frictional force value. Actually, this is the maximum limiting force that the contact will develop. That contact will develop, right? Please, very important points. Okay, now we'll see the meanings of all this point in a language format. Okay, clear? See, just note it down, these particular points. Okay, see these points, actually this point is written in this slide only. Okay, no problem. So we have already discussed that points, right? Now come to this Coulomb's law of friction. Come to this part of Coulomb's law of friction. Very important, very important. Again, the magnitude of maximum static frictional force. Again, most of the time student will do a mistake here. What is that mistake? See, maximum static friction force is directly proportional to normal load. Actually, most of the students will say like this: frictional force is proportional to normal load. It is totally wrong. It is totally wrong. It is totally wrong. Why? It is the maximum static frictional force which is proportional to normal load. Okay, not the friction force. There is a difference between friction force and the maximum static frictional force. There is a totally a difference between both these terms, right? Always remember this thing. This is wrong, right? We'll say like this: maximum frictional force is proportional to normal load between the contacting surface, right? This is the Coulomb's law of friction. Okay, and if we remove this proportionality sign, if we remove the proportionality sign, a coefficient of static friction will come. So coefficient of static friction, mu s. So always remember the formula for this formula for the friction, mu s n, mu s multiplied by n. This formula is valid only when the maximum frictional force is acting. When the maximum frictional force is acting, then only this particular formula is valid. Otherwise, you will not apply this particular formula. First, you have to ensure that maximum frictional force is acting or not. How we can ensure that particular point? See, if the impending motion condition is there, then only we can say the maximum frictional force is acting. And if the maximum frictional force is acting, we can use this particular formula. Right? This particular point is clear? Okay. Now, mu Sn, it is the point. Now, it is for the static condition. It is for the static condition. As we move on to the dynamic condition, there will be a little less value of the frictional force will be there. There will be very little, a slight drop in the frictional force value. There will be a little slight drop in the frictional force value. Why? Because, see, this is for the static part. This for the static. This is for static, right? See, for the dynamic part, we'll write it like this. Frictional force in the dynamic condition. D stands for dynamic, right? It equals to mu k into n, right? Where mu k, please understand this particular point, very important. Coefficient of kinetic friction. Coefficient of kinetic friction, right? So always remember, whenever the dynamic condition is there, you have to use coefficient of kinetic friction. Whenever the static condition is there, you have to use mu s, coefficient of static friction. Okay, coefficient of static friction, right? Right, always remember this particular point. Okay, so one more important point, mu k is less than mu s, and because of this only you will find dynamic force is less than maximum static force. Is less than dynamic force will be less than maximum static force. So obviously frictional force will have a maximum value in the static condition only. Frictional force will have a maximum value in the static condition only. Very, very important point. Guys, always remember this. Always. Friction will have a maximum value in the static condition. Whenever it comes to the dynamic condition, little bit drop in the value of the frictional force. Okay. Always remember this point. Right. Now, second point, some important points for the Coulomb's law only. Magnitude of the frictional force is independent of the area of the contact, right? Independent of the area and also independent of the relative velocity, right? Please remember this particular point. But actually both these points are valid for the up to certain limits. Up to certain limits these points are valid, right? Always remember, it is not a general statement. It is not a general statement. It will be valid up to a certain limit only, right? Correct? Now, see. This point is clear. Next, angle of friction. Again, very, very important. If you know the angle of friction concept, most of the friction quotients or the numericals will be very easy for you. If you know the concept of angle of friction, it will be very helpful, and we'll be using this angle of friction concept in the wedge problem, right? In the GATE 2021, they've asked the wedge question from in the civil engineering basically. So definitely this is a very important question in the friction chapter, that is what? Wedge problem. They have asked already in civil engineering. In mechanical also they can ask, right? In mechanical they can also ask, right? Always remember, angle of friction, what is the importance of angle of friction? That we need to understand, right? That we need to understand. See, angle of friction is, first of all, definition. Angle of inclination, it is the inclination of a resultant force of friction and normal direction at the point of impending motion condition. See, first of all, this is very important. Please put a star mark here. It is very important. How? See, let's suppose there is a block. Okay, there is a block, and let's suppose there is force P is acting. Now, if force P is acting and it is having a relative tendency of motion, definitely friction force will start acting. Normal reaction, this is what? Frictional force. Let's suppose, see, as they have mentioned impending motion condition, right? So I will be putting here maximum value. Always remember, whenever they will say the maximum frictional force value, right, or the impending motion condition, it is totally same. If they say impending motion condition, maximum frictional force. If the maximum frictional force is acting, it means what? Impending motion condition, right? Now, this is the case. Definitely this is along the tangential, this is along normal. There will be some resultant value. Guys, right? So what is that resultant value? That resultant value will be what? Under root this maximum square plus normal square, right? This will be the resultant value. Clear? If this is the resultant value, now see, from the definition itself, resultant will be like this. And what is the angle of friction here? Angle of friction will be this one. Angle of friction will be phi s. Basically, S stands for static condition, right? Phi s. I hope this particular point is clear to everybody. Guys, tell me fast. This particular point is clear? This is the phi s. All of you, it is clear, guys? Phi s, right? This is angle of friction. Now, if this is angle of friction, can we write it like this? 10 phi s. Can we write it like this? See, 10 phi s will be what? Maximum frictional force divided by normal. Okay, it will be like this, mu s, and finally you will find what? 10 phi s equals to mu s, right? This is again very important. In most of the questions, they will not mention the coefficient of friction directly. They will say the angle of friction. So how you can calculate the coefficient of friction from the angle of friction? This is the relation. By which we can calculate the coefficient of friction from the angle of friction. So tangent of a angle of friction will become what? Coefficient of static friction. Again, very, very, very important. Okay, very important. Clear, guys? Very important part. So always remember, resultant, what is angle of friction? The resultant, that is angle made by the resultant with respect to normal. Is nothing but the angle of friction. So basically we can say inclination of resultant from the normal is nothing but the angle of friction. Clear? So it is phi s because we have considered the impending motion condition, right? That's why we have written maximum here. So resultant you can calculate it by this. This is also important. Resultant you can calculate by this, and if you need the coefficient of friction and angle of friction is given, use this relation. Now angle of repose, again next, a very small thing but again very important also. See, if this is an inclined surface, and in the inclined surface a block is like this, right? A block is like this. Definitely some weight will be there, but if you resolve that weight, if you resolve that particular weight like this, let's suppose this is alpha, this will be W sine alpha, and this will be what? W cos alpha. Okay, this is writing I'm here. This vertical force on the inclined plane will be W cos alpha. Now, see, there will be normal reaction and frictional force value. Normal reaction will be like this. But in which direction the frictional force will act? Upward or downward, guys? Tell me first. Upward or downward? In which direction the frictional force will act? Upward or downward? Guys, tell me. Upward or downward? Friction force will act in upward or downward? Guys, tell me fast. Upward or downward direction? Yes, Deepak, correct. Upward direction. Why? Because it has a tendency to go down. So definitely friction force will oppose that. So it will act in opposite direction, right? Now, from here, this particular point is clear that body is trying to going into the downward direction, and friction force will oppose that motion. So let's suppose there will be some one particular angle at which impending motion condition is there. Actually, there will be some particular angle alpha. There will be some particular angle alpha at which impending motion condition will be there. Basically, it means that at alpha value, let's suppose I am calling alpha as an angle of repose. It is what? Angle of repose. So if alpha is the angle of repose, then we can say, yes, Gautam, up. If we are saying angle alpha is what? Angle of repose, then we can say body is under a condition of impending motion. It is not moving downward, but it is just about to move in the downward direction. Okay, it is clear. So whenever alpha is the angle of repose, basically when we can say under impending motion condition. Right. So it is the angle of inclination corresponding to the impending motion condition. So whenever the impending motion condition is there, so corresponding alpha, corresponding inclination of an inclined plane will be known as angle of repose. It will be known as what? Angle of repose, right? Now, coming to the next part, tipping. Now, this is very, very, very important part, guys. And most of the students will find it very difficult to solve questions from the tipping, in which block is there, which is what? Tip is there, tipping condition is there. Previously in the gate examination, they have already asked one question. Okay, definitely they can again ask from this particular topic also. Again, the concept, obviously concept will again repeat it, but question will not repeat, but concept will definitely repeat. And this particular concept, most of the students find difficulty in solving questions from the tipping concept. Now see, very carefully observe this particular concept, very important. See, when we say, let's suppose this is a block, it is like this, it is acting, it is just lying on the horizontal plane. Okay, no force is acting. Can you tell me the location of normal reaction? Can you tell me the location of normal reaction? Guys, tell me fast. Can you tell me the location of normal reaction? Weight is acting, na? So definitely normal reaction will be there. Obviously frictional force will not be there here, because as there is no tendency of motion, normal reaction, so obviously it will be there. But location, where is the location? At what location normal reaction force will be acting? Guys, tell me fast. Where the normal location, where the normal force will be acting? Obviously base, but where? Here, 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 here. Which option? Harshvardhan, correct, base, but where? I'm asking the location. Location. center. Correct, correct, obviously correct, correct, totally correct. All of you are correct here. You are saying, see, this is weight. Definitely normal reaction will be acting like this. Absolutely correct. Now, see another case. Now, in this particular case, scenario, again, normal will be acting like this at center only. Again, in this case also, normal will be acting like this. Yes or no? Yes or no? Generally, we draw like this. But in the tipping case, you have to be very careful about the location of normal reaction. You have to be very careful. Where should be the location of N? Where it should be acting? Where it should be acting, guys? Tell me first. Where it should be acting? Here you have said it is acting at the center. Totally correct. Totally correct. But what about this question? In this scenario, where the location of normal? Where is the location of normal? Where it is acting? Right of the base. See, how can you confirm the position or the location of normal? On which concept can you identify? See, basically, how can you identify the location? Is there any concept? Is there any logic? On what basis you can say it is on the right, it is on the left, it is there, it is here? On what basis you are saying? Right? See. Understand very carefully. Understand very carefully here. When you apply a force P, when you apply a force P, when you apply a force P, see, when you apply a force P, there is some rotational tendency is there. A rotational tendency is there. Correct? Rotational tendency will be there. So when the rotational tendency is there, so most of the weight will be shifted here. Most of the weight will be shifted here. Most of the weight will be shifted here. Where? In the right direction, right? So normal obviously will shift towards right. Normal will shift towards right. Yes, Deepak, correct, absolutely. But how we can actually calculate the location? Yes, it is the point where our normal is acting. How? See, just to prevent the tipping case, you have to take the moment equilibrium. You have to take the moment equilibrium. Location of N can be found out by using moment equilibrium. Why? See, when it is in equilibrium condition, right? If it is under equilibrium condition, we can take the moment, and from the moment equilibrium equation, we can calculate the normal reaction location. How? See. But first of all, see, whenever the force is acting like this, body is having a rotational tendency. If it is having a rotational tendency, weight will be shifted towards right direction. So normal will not be acting at the center. Normal will not be acting at the center, right? Remember this particular point. Now, we'll see how we can calculate the location of normal. See. I don't know position of normal. I've just drawn like this. Okay, there will be some center. Okay. See, here you should write location of normal can be found out moment equilibrium equation. Moment equilibrium equation, correct? Location of normal can be found out by using moment equilibrium equation. How we can apply? See. Let's suppose this is center. Let's suppose I am taking the moment equilibrium now. So anywhere I can take the moment. At any point I can take the moment, right? So if I take the moment about the center of mass, okay, equals to 0. I'm taking the moment, sorry, I'm written the force here, it should be moment. I'm taking the moment about center of mass. Here I'm taking the moment, right? So first of all, you need to understand the distances. Let's suppose here the distance is h, and from the center it is having a distance x, like this. So let's suppose I'm taking the moment. Now obviously weight is acting through this point only. Weight is acting through this point, so no moment will be counted. No moment of a weight will be counted here. So P at this point will have a clockwise moment, P into h, right? Normal reaction will be what? Anti-clockwise minus n into x equals to 0. So you can calculate the value of x from here. You can calculate the value of x from here, basically the location of normal, right? But you need to understand a very important point here. If n lies outside the base, if n lies outside the base, then tipping will occur, right? So write it down. If n lies outside the base, then tipping will occur. Very, very important point. If you want to confirm that tipping will occur or not, just check the location of n. If it is acting outside, if its location comes outside the base, if its location, after calculating like this, if the location comes outside the base, it means what? Tipping will be there. Definitely, for sure, tipping will be there. Clear? Everyone, guys, it is clear to everybody? Tipping will be there. Okay, so tipping will be there if n lies outside, right? Very important point. But what is the limiting point here? What is the limiting point? Corners are nothing but the limiting point. So just to avoid the tipping, we'll be putting the normal at the what? We'll be putting the value of normal at the corner. We'll be putting the value of normal at the corner, right? Clear? So we'll write it in the next page. Limiting condition. We'll write it like this. Limiting condition. Okay, this is force P. Now we'll see the limiting condition. Limiting condition basically means just to avoid tipping. To just avoid tipping part. Okay, to just avoid the tipping. N will be at and normal reaction will be at the corners. At the corners, right? N will be at the corners. Okay. So if it is lying outside the base, tipping will be there. For sure, tipping will be there, right? And if it is at the corners, that is the limiting condition. Basically, it means what? To just avoid the tipping case. Okay. Clear, guys? Please note it down. Very important concept. You will definitely find a question from this topic. You will definitely find a question from this topic in your GATE examination, both mechanical and civil. Okay. Please note it down fast. Clear? Now moving to the next part, guys. I hope ये चीजें आपको यहाँ तक सब अच्छे से क्लियर हो चुका होगा. I hope. Okay. कहीं किसी को डाउट है अभी तक यहाँ पे किसी भी पॉइंट पे? Anyone is having any doubt, any confusions or any questions they have, any query they have, you can ask. Okay. Any doubts, any confusions, anything you want to ask up to this point? Anything, any questions, guys? Everything is clear? Everything is clear, guys? Okay, great. Now, again, very important part, that is the wedge friction. Next part, the wedge friction. Very, very important. We'll see a very important shortcut method to solve this wedge friction numericals. We'll discuss a very shortcut method for this wedge friction. Okay. And it will definitely help you out in the examination, because this method is very easy and very easy and also very less time consuming, right? See, in the wedge friction, what will be there? Assume a diagram, assume a situation like this. Okay, this is a general case for the wedge friction, right? See, this is your wedge, okay? This is your wedge. This is the load that you want to lift with the help of this wedge. Clear? This is the load that you want to lift with the help of this wedge. So you will be applying a force in the wedge like this, and load will be lifted like this. Clear, everyone? You will be applying a load in the wedge, and the load will be lifted in the vertical direction. Clear? Now, let's suppose they have also mentioned the angle. Let's suppose this angle they have mentioned as theta. Okay. Now, see, we'll draw the free body diagram here. First of all, we'll draw the free body diagram. Okay. Free body diagram will help us in visualizing the whole system, right? Always remember this particular thing. Free body diagram is very important and very first task. Whatever the first step in every question of engineering mechanics is just to draw the free body diagram. Clear? Okay. So we'll draw the first of all the free body diagram of load. Carefully observe these points, right? If you are able to solve this question, and if this question is clear to you, then you can solve any type of question from the wedge. It's my guarantee. If you know this particular concept, if you know the, if you have solved such type of question, this is a standard numerical, okay? Standard question. So if it is clear to you, then you can solve any type of wedge question. Any type of wedge question, okay? Clear? Now see. So this is the load. Now, we'll draw the, obviously load is have a connection, have a joint, or we can say it is touching the wall. So normal direction will be there. Okay, it is having a contact with the wall. So normal direction will be there, right? Let's suppose frictional coefficient is also given, and obviously it will be given. Then only the concept of friction wedge will be there, na? Otherwise, if there is no friction, then what is the use of wedge, right? So can you tell me the frictional force direction on the load? If I am talking about with respect to wall, upward or downward? Frictional force will act in this in the upward or in the downward direction. Guys, tell me fast. Upward or downward direction? In which direction the frictional force will act? Upward or downward? See, I am talking about the load with respect to this wall. Just you need to consider the relative tendency of motion. Relative tendency of motion. How you will check relative tendency of motion? See, I want to check the relative tendency of this load. So I have to be at this wall only. From this wall, I will observe the load. See, when the wedge is coming like this, load will be moving upwards. So load is having a relative tendency of motion in the upward direction, right? So friction force will act in the downward direction. Deepak, correct, absolutely correct. It will be acting in the downward direction. So let's suppose N1, F1 is there like this, okay? Now, I will also draw the wedge here. Right. Now, here load and wedge is having a contact, so definitely friction force, normal force will be there. Okay, so normal will be like this, perpendicular to this incline. Let's suppose I am calling it as N2. But what about the friction force? What about the friction force? Friction force act in this downward direction or in the upward direction? Tell me fast. In the downward direction or in the upward direction? Tell me. Load is having a contact with the wedge. Load is having a contact with the wedge. So on this surface, frictional force in this upward direction or in this downward direction? Tell me fast, guys. We have already discussed how to check the direction of frictional force. See, always see. I want to check the friction force on the load. So first of all, I should know what is the relative tendency motion, correct? So for checking the relative tendency motion, I will be on the wedge. Okay. Now, as you know, we are applying the force on the wedge. Okay, we are applying the force on the wedge, right? So if we are applying a force on the wedge, so wedge is having a tendency of moving towards left, and I am on the wedge and observing the load. So if I am moving in the left direction and observing load, so definitely for me it is moving in the upward direction. It will be in the upward direction. So definitely friction force will act in this downward direction. Yes, Deepak, correct. Absolutely correct. In the downward direction. Okay. What about the wedge? See, this is the P load, right? Normal reaction will be like this, N2. And obviously it is moving in this direction towards left. Frictional force will oppose the downward, oppose this motion. So it is moving in the left. It is the relative motion of the wedge in the left direction. So definitely friction force will act in such a way that it will oppose the movement of the wedge in the left direction. So obviously frictional force will be like this. I hope this is clear. And here the N3 will be like this, and this F3 will be like this. Now this all are the forces. See how many forces are there. See how many forces are involved in this particular scenario. Lot of forces are there. So it is very difficult for us to solve each and everything here. So you just need to apply one concept here, that is angle of friction. You need to apply one important concept here, that is angle of friction. With the help of angle of friction, it is very easy for you to solve such type of question. Okay. Angle of friction concept, it is very important here. Okay. How we can utilize that? See. Normal and frictional force is there. There is one resultant, and whatever the resultant is making an angle with the normal, it is called frictional angle. So let's suppose it is like this. R1 angle phi, frictional angle phi, right? Obviously here also resultant will be there, R2 angle phi. Here also R2. Here also R3. What about the angles? See, I will mention the angles here. Now see, from the vertical, normal will have angle of theta. Why? Because see, this inclination is what? Theta. It is already given in the question. Already given in the question. Theta they have mentioned, right? It is also what? Theta, right? Clear, guys? It is clear to you? Okay, because here the wedge also inclination is what? Theta, na? From the horizontal. So whatever the normal you will draw, na? So it will have an angle theta from the vertical. Okay. Write it like this. Okay. Now see, you have drawn the resultants. Now please carefully observe, guys, very carefully. If I talk about the load, load is also having some weight. So let's suppose weight W is there. Now just tell me one thing. Tell me one thing. How many loads are acting on this load? How many forces basically? How many forces are acting on this particular load? How many forces are acting on this particular load? Guys, tell me fast. How many forces are acting? If you consider this load, how many forces are acting on this load? Three. Yes, Deepak, absolutely correct. Absolutely. How? See, we have taken the resultant for friction and normal, so we'll consider resultant only, right? We have taken the resultant of friction and normal, so we'll take resultant only. So R1, R2 and W, three forces, and under impending motion condition, we can assume equilibrium condition. And if the equilibrium conditions are there, yes, Madhusudan, yes, absolutely three. And if the equilibrium conditions are there, you remember in the Lami's theorem we have discussed what? Body subjected to three forces, body under equilibrium, then all the three forces will be what? Concurrent forces. Guys, tell me this particular point, very important. Body under equilibrium condition, three forces, all three forces must be concurrent. How the concurrent force system will look like? See. See, this is the W, it is acting. It is the R1, right? So from the horizontal, they have given the angle phi. Okay, no problem. R2, from the vertical, it is having angle what? Theta plus phi. Like this. So you can easily solve what? This particular question by using the Lami's theorem. You can solve the question by using the Lami's theorem. Yes, Deepak, absolutely. Lami's theorem can be applied here. Yes, correct. Lami's theorem can be applied here. In the similar way, we can have also the wedge. We can also have the wedge portion. Right? So in the wedge, see, P force is there, R2 force is there, R3 force is there. Only three forces. Again, body under equilibrium condition, three forces. All three forces must be in concurrent forces. All three forces must be concurrent forces. Clear? This is clear to all of you? This is clear? So very important, you will find a question of wedge friction. You can find a question from the tipping. From both the topics, see, there are some, I can definitely say there are some chances that from the tipping or from the wedge friction, you will find a question. From both the topics, any of the questions, any one question from both the topics, it will be there in the gate examination. Either from the tipping or either from the wedge. Definitely. For mechanicals and civil, definitely question will be there. I hope this is clear, guys. Okay. Now, moving to the next part, centroid and moment of inertia. Okay. We'll do this part by we'll have a just 5-minute break here. We'll take a just 5-minute break, and after 5-minute break, we'll come to this part, and again, we'll finish the entire mechanics part. Okay. In just 2 hours only, we'll have just 2 hours more left. We will complete the entire engineering mechanics part, but we'll have a just 5-minute break, guys. We'll again meet after 5 minutes. Just after 5 minutes, we'll again meet. Okay. Welcome back. Welcome back, guys. I hope I'm audible. Please confirm, guys. I'm audible. Guys, okay, great. We'll start the session. Okay, we'll start the session. See, next topic we are having centroid and moment of inertia. Centroid and moment of inertia is again a very important topic. Okay, not just from the engineering mechanics point of view, also from the strength of material, right? Theory of machine design, and if I talk about civil engineering, steel, structure, RCC, and even in the fluid mechanics for both mechanical and civil. See, concepts of centroid and moment of inertia are very helpful in other subjects also. Not only in the engineering mechanics, but also in other subjects. You will find an application of this centroid and moment of inertia, right? See, whenever I ask the question of what is centroid, most of the student will, or even 90% student will say it is a center of area. They will say center of area. See, it is the geometrical. Actually, they are correct. It is the center, but not just for area only. It is the geometrical center, correct? It is what? Geometrical center. So geometry can be line, geometry can be area, geometry can be what? Volume. Okay, all those things will be there. So whenever we are talking about the centroid, always remember, whenever we are talking about centroid, it is what? Geometrical center. Okay, geometrical center. It is what? Geometrical center, correct? Geometry can be solid, it will be what? Line, area and volume. And for us, area of a center is generally more common in our analysis. That's why in general we'll say centroid is nothing but the area center. Okay, but we should also know that it is also line center, it is also volume center. So centroid is nothing but the geometrical center. Correct, guys? Okay, great. Now see, what are the different centroid? See, basic centroid formula you already know. We'll discuss some different centroid formulas. Okay, I think most of the students already know, but some of the students will not know about that particular formulas. So that all those things will be clear to you, right? In your formula sheet, right? In your formula sheets, all those formulas should be there. Otherwise, see, let's suppose some given geometry is there, and for that centroid formula is not known to you, then obviously you will find a difficulty in solving question. You will find difficulty in solving question if you don't know the centroid of a standard figures. So please, everyone should learn all the centroid formulas, all the moment of inertia formulas. Okay, of the at least for the standard figures. For the standard figures, you should know all those things, right? Okay, just 1 minute. Okay, now see, first case that we'll discuss, unsymmetrical triangle. It is again very important. Simple triangle everybody knows, right? Unsymmetrical triangle is a different case, right? It will be like this. Unsymmetrical triangle. Okay, let's suppose this is x, this is y, right? So you need to remember all those centroid and moment of inertia formulas for standard figures. So I have first drawn the reference axis, reference origin I have drawn, so that it will be clear to you from where I am measuring the centroid, right? So whenever you are telling some position, first of all you need to define what is the reference from which you are measuring the position, right? So for the reference I have drawn this coordinate system x and y. Clear to you? Now see, this is unsymmetrical triangle. See, we'll mention the some important dimensions here like this. This particular dimension, let's suppose we call it as A, and this complete base is known as B, right? Height h, let's suppose like this. Then what is the centroid, guys? What is the centroid? Centroid will be what? See, x bar will be what? A plus B divided by 3. A plus B divided by 3, right? And what is y bar? Y bar is nothing but h by 3. Clear, guys? Guys, tell me it is clear. It is very important formula, guys. Very, very important. Okay, please always remember these particular things. This is the case of unsymmetrical triangle. This is the case of unsymmetrical triangle. Please mention here. And see, one of the frequently mistakes that student will do is what? They will take A this one and they will take the B this one. Okay, please be careful while you are remembering any formula. Please be careful. Okay, this is A and this is total B base. Please don't take another dimension as B. Most of the students will do a mistake like this. Please understand, this particular distance is A and this total is B. Okay, so let's suppose if I draw in a different manner. If I draw in a different manner like this, and let's suppose this is the vertex, this is A and this is what? B. Okay, so if I draw in a different manner, see, always remember what is the A segment. What is A segment? From the vertex you will draw the vertical line. From this point you will draw a vertical line. So from that vertical line, what is the total distance from the origin? It is what? A. And B is nothing but the total base of the triangle. Total base of the triangle, right? So always remember, for the unsymmetrical triangle, these are the what? Centroids. Okay, so always remember centroid. For the centroid I have drawn this particular reference. Okay, now another figure that is important is quadrant or semicircle. First we'll check the semicircle case, then we'll discuss the quadrant case. Okay, this is, let's suppose, first case. That, see, all the basic one you already know. Now let's suppose if I talk about the semicircle case. Right, for the semicircle case, what will be the centroid? See, x bar, if I talk about x bar, from x bar it will be what? R, radius only. But what is the y bar? 4r upon 3 pi. 4r upon 3 pi. Yes, it is clear to everybody. Guys, tell me fast. It is clear? This unsymmetrical triangle is very, very important. Most of the students would, I think, don't know about this unsymmetrical triangle, centroid. So please note it down in your notes. For the unsymmetrical triangle, these are the coordinates. For the centroid. For the semicircle, these are the coordinates. Okay. See, next we'll draw for the quadrant. Okay, for the quadrant we are having like this. Four r upon 3 pi. Four r upon 3 pi. Like this, we have a coordinates for the quadrant also, right? Done. Deepak, yes. Please note it down fast. Note it down fast, guys. Please note it down. Okay. So next, this is quadrant. Next, another important thing is what? Ellipse. If I draw for the ellipse also, see, fourth one, for the semi-ellipse, let's suppose, for the semi-ellipse I am talking about. See, this particular dimension is A, and this particular dimension is what? B. So for this case, see, for this case, y bar is equals to 4b by 3 pi. Guys, again very important, 4b by divided by 3 pi. It is what? Semi-ellipse. It is the semi-ellipse. This formula you should also remember, right? Semi-ellipse. Clear? If we take the total ellipse part, it will be the center of the ellipse, like circle. Okay, but please remember, this dimension is A, this dimension is B, but in quotient they will give the entire minor axis and major axis. They will give the entire. Okay, actually this is A, this is B. In the quotient itself, they can give like this. They can give A as this. Okay, they can give A as this. But if you put this A value here, definitely the answer will be wrong. Definitely answer will be wrong. Clear? Clear? Now, see, we'll see the moment of inertia part. Now, we'll see the moment of inertia part. Okay? Clear? Again, see, this unsymmetrical part and this unsymmetrical triangle part, semicircle, we'll mention here. Semicircle. This is quadrant. Right, this is quadrant and this is what? Semi-ellipse. Right? Clear? Now, we'll move on to this moment of inertia part. See, we'll move to the moment of inertia part. See, you should know moment of inertia are of two types: area moment of inertia and mass moment of inertia. Right? Area moment of inertia is nothing but the second moment of area. Second moment of area. And what is mass moment of inertia? It is nothing but the second moment of mass. Right? This is the mathematical formula you should know. This is the mathematical formula you should know. Area moment of inertia is what? Second moment of area. It is second moment of mass. Clear, guys? It is clear? Okay. Now, what are the different formulas that you need to remember? See, for the area moment of inertia, you already remember most of the formulas, right? See, let's suppose if I talk about the rectangle part. Always remember, let's suppose you need to calculate the moment of inertia about this xx. Okay. Let's suppose this height is h and this base is b. Complete base b, right? Complete base b and complete height h. So always remember, if you want to calculate the moment of inertia about x, whatever the height which is perpendicular to that axis, it will be what? It will be what? See, will be h cube. You have to take the cube of that particular dimension. See, most of the students will find confusing which dimension has to be cube, which dimension has a cube. Only those dimensions you have to keep as a cube which is perpendicular to the axis. Let's suppose I want to calculate xx moment of inertia. Dimension which is perpendicular to axis is h, right? So bh cube. If you want to calculate moment of inertia about yy, hb cube by 12. Why? Because b is perpendicular to yy axis. B is perpendicular to the yy axis, right? Clear, guys? So this is the point that you need to remember always. Okay, and then some other examples, like for the circle. For the circle, see, for the circle, it is a symmetrical, so along xx, along yy is same pi d to the power 4 divided by 64. Pi into d to the power 4 divided by 64, right? Clear? Clear, guys? Okay, great. See, such basic formulas you should know. Now, very important part, very important. The parallel axis theorem and the perpendicular axis theorem. And after that particular point, we'll discuss the free vibration part also. Okay, such basic formula you should know. Okay, such basic formula. But which theorem are very important, which relates different moment of inertia? See, parallel axis theorem, very important theorem, because in some cases where you need to calculate the moment of inertia, you have to use this parallel axis theorem. How? See, let's suppose this is the body you are having, which is having area A, right? Area A it is having. Let's suppose it is having a centroidal axis like this. It is the centroidal axis like this. Okay, CC is our centroidal axis. Okay, please mention here this axis is nothing but centroidal axis. Now see, very important. Now if you want to calculate, the moment of inertia about any axis which is parallel to this centroidal axis, you can easily calculate. How you can calculate? See, let's suppose there is another axis. Let's suppose it is AB axis. It is parallel to our centroidal axis and it is having a distance d like this. So you can easily calculate the moment of inertia of the body about this centroidal axis. See, what is the relation? Relation is like this. Moment of inertia about AB equals to moment of inertia about the centroidal axis, body's own moment of inertia about its centroidal axis, right? ICC is what? It is the moment of inertia of a body about its own centroidal axis, okay? Plus whatever the area body is having into distance d square, right? This is what the parallel axis theorem, and it is very helpful for us to calculate the moment of inertia by using this parallel axis theorem. We'll see the application. We'll also see the application part. But first of all, please understand this particular point. Body is for calculating the body's moment of inertia about any axis which is parallel to its one of the centroidal axis. Body is having two centroidal axes. If you're talking about the planar bodies, along horizontal and along vertical, two centroidal axes are there, right? So any centroidal axis you can take. So let's suppose this is the centroidal axis. If the axis is parallel to this centroidal axis, then we can use this relation. To calculate the moment of inertia of the body about this axis. Clear? Guys, this is clear to everybody? Okay, very important, right? Next, perpendicular axis theorem. Again, see, let's suppose there is a body like this. Right, like this. So if we want to mention the horizontal and vertical centroidal axis like this, x, y. These are the two centroidal axes which are lying on the plane of the area. Plane, so basically it is what? The plane. It is two centroidal axes which is lying on the area only. On the plane itself it is lying. On the plane, two centroidal axes are lying. But what about the third centroidal axis? Which is passing through this centroid but in the perpendicular direction, that is z. And this axis is also known as polar axis. Okay, it is known as what? Polar axis. Any axis which is perpendicular to the plane, and passing through the centroid of the plane, then that particular axis is known as polar axis. Please always remember, any axis, first of all, any axis which is perpendicular to the plane and also passing through the centroid, it is known as what? Polar axis. And if you want to calculate the polar moment of inertia, you will have a formula like this: Ixx, Iyy. Right? Clear? Please note it down fast. Clear? Clear, guys? Tell me first. Clear, Deepak? It is clear to everybody. Area of a ellipse you are asking. See, we have discussed na. We have discussed this semi-ellipse part for the centroid. Okay, we have discussed the we have discussed the semicircle part. We have discussed the quadrant of a circle. Please mention quadrant of a circle. Okay, and if you want to calculate, let's suppose this ellipse again. Let's suppose if you want to calculate the area of a ellipse. See, this is the A dimension, this is the B dimension. Okay, major axis, minor axis. I'm not taking the whole axis, right? Clear, Deepak? I'm not taking the whole axis. This is only A. This part is A, and this part is B. So if you take like this, then area will be what? Pi A to B by 4. But in some cases, if you see like this, please don't be confused with the formulas. See, let's suppose in this particular case, it is what A, it is what B. So in this case, area will be pi A into B. So actually, there is a difference between both things. Clear? It is clear, Deepak? It is clear to you? Okay, great. Please remember which dimensions you are taking while putting the values in the formula. Please be careful which values we are putting in the formula. Okay, both the formulas are same, but actually here we have taken A as the whole axis, but here we have taken A as a half of the axis, right? Okay, parallel axis theorem is clear. Perpendicular axis theorem, I think it is also clear, right? So you can use it. Now, free vibration, again last topic of the civil part, last topic for the civil engineering students. For the civil engineering students, this is the last topic that we'll have, right? Please be attentive, and obviously for the mechanical people also, it is in the theorem machines. So definitely we'll be discussing that also, but please be attentive in this particular part because it is very important, and only it is very easy also, because in theorem machines we'll discuss also, but as far as civil engineering student is considered, direct formula based questions the gate has asked previously gate has asked the direct formula based question for the civil engineering student. So it is very easy, just be attentive in the session. Okay, right. See, when we say free vibration of single degree of freedom, okay, so let's suppose this is the spring is there, a spring is there. Okay, now it is basically it is undeformed, basically it is what? Undeformed, right? Please be careful. Now if I put some mass, or if I attach some mass or body or block to this, what will happen? Obviously it will deform, correct? It is correct. If I attach a mass to this spring, definitely it will deform. Okay, see, if I attach a mass here, so definitely it will deform. Okay, so I have attached what? A mass here, so it has deformed. It will deform by this particular distance. Let's suppose this is delta. This is the delta by which it has deformed, right? So by delta it has deformed. Now it is under equilibrium condition. Okay, now if it is under equilibrium condition, we can write it like this. Mg, that is the downward force which is acting in the downward direction, and the spring force will be what? K into x. Spring constant multiplied by the deformation. Deformation is not is what? Delta. Guys, everyone is clear about this? Guys, tell me. It is clear? Okay. Now see, you just have attached a mass here, so it has deformed like this. Now, it is under equilibrium condition. Now, if you just disturb this mass, what will happen? If you disturb this mass, what will happen? Guys, tell me fast. If you disturb this particular mass, what will happen? What will happen? Tell me. If you just disturb this mass, what will happen in the spring? What will happen in the spring? Guys, tell me. Will there be any some vibrations? Will there be any vibrations in the system? Yes, absolutely. Vibrations will be there in the system. Why? Because you have disturbed the mass. Now, definitely, if you disturb the mass, the vibrations will be there. Yes, Deepak, absolutely correct. Vibrations will be there. Okay, how the vibrations will be there? See. Like this, the vibrations will be there. Okay, it is moving upward and downward, moving upward and downward. Forever it will do like this. Until unless there is some effect which opposes this particular motion. Until unless some effect will be there so that it can opposes this motion. Why? Actually, what has happened? See, what has happened? Why it has started vibration? Why the vibration has started? See, why? When you just displace the mass, some kind of potential or strain energy is stored in the spring, and that energy is stored in the spring, and because of this energy, potential energy change and the kinetic energy change will occur simultaneously. Kinetic energy will change into potential energy change into kinetic energy. So there will be just transformation of energy will be there. So for having no vibration, we have to eliminate the energy from the system, right? See, you have provided the energy, because if you displace the mass, some potential energy will be stored, and if you release it, what will happen? That it will convert into kinetic energy. So conversion of energy will be there. Conversion of energy. Right. Conversion of energy will be there. Potential to kinetic and kinetic to potential. Potential to kinetic and then kinetic to potential. So this conversion will remain there. This conversion will remain there forever until unless some dissipating effect will be there. Let's suppose air resistance is also there. So definitely air resistance will oppose this motion, and finally it will eliminate by slowly it will eliminate the energy from the system. So always remember, if there is a energy is available in the system, this conversion will be there. The conversion will be there forever if the energy is present. If energy is not present, then we can say the vibration will be there forever. If obviously if energy is not there, how the conversion will be there? So if energy is there, conversion will be there. As simple as that, right? I hope the point is clear to you. Conversion of energy, potential to kinetic, kinetic to potential. Okay, it is clear to everybody? Great. Now see, what are the important formulas that we need to understand? Okay, direct formula based question you will find in the vibration part. Direct formula based. Okay, first of all, omega n, that is the natural frequency formula. K by m, unit radian per second. Important points are what? K is what? Stiffness or spring constant, we can say. Unit is what? Newton meter, right? Mass, unit kg. Please be careful while putting the values. Why? Because generally in the exam they will give the stiffness in kilonewton per meter. They will give the value of stiffness in kilonewton meter, and if you directly put kilonewton per meter in this equation, then you will get a wrong answer. Please be careful. Okay, always put the value of stiffness in Newton meter in this formula. Never put the value as kilonewton per meter. So you have to convert it into Newton per meter. Okay, remember this particular point, very important. So this is the natural frequency that you need to calculate. Now this formula is applicable in different scenarios, and you need to understand what are those scenarios. What are those scenarios you need to understand? Mass basically kg. See, this is the radian per second. Natural frequency. This is what? Natural frequency. Now, what are the different scenarios that we'll have? Okay, different scenarios. See, under this case, this formula is applicable, right? This is the first point. Second case, we can say like this. Like this is the second case. What is the third case is also there. See, on the inclined plane also. Like this. So in all three cases, you can apply this particular formula. But remember, we don't consider friction values. We don't consider friction in this particular case because we are assuming frictionless system. Okay. Because if friction involved, dissipating effect will be there. Dissipating effect will be there. So, but actually in our case, in our syllabus for the civil engineering, we'll assume a frictionless cases. Okay, so on all these cases, you can apply this particular formula, right? So please note it down fast, guys. Please note it down. Done? Tell me fast. Done, all of you? Done, done. Okay, great, Deepak. Great, great. Now see. Okay, so now another point that we need to understand here is that arrangement of the different springs. Springs can be connected in series or in parallel. We can connect. Okay, now see. Now connections. Connection of a spring. Okay, let's suppose spring are connected in series. Like this, if there is a case like this, K1, K2, like this. Okay, there is a series case. Then another case I will draw like this. Okay, now tell me, in case of series, right, this is series case. This is parallel case. Right, now understand the formula. Very important here. Very, very important. See, what is the formula? K equivalent stiffness equals to 1 upon K1, 1 upon K2. This is the formula for the series case. But if you talk about parallel, equivalent stiffness will be K1 plus K2, like this. So please remember this particular formulas, guys. Right, very important formulas. Series and parallel case. So they can give the values of different K, and you directly put the value of K here. And if they ask calculate the natural frequency, please in the formula of natural frequency put K equivalent then divided by mass. Right? Okay, be careful about this. So if they ask to calculate the natural frequency, just put it like this: under root K equivalent divided by mass m. Clear? This particular thing is clear to everybody, guys? Clear, na? Yes or no? Fast, tell me. Clear? Done, done. Okay. Now, see, when we have written this natural frequency, na, you can also write it some important points like this here. Time period of oscillation, they can even ask. 2 pi by omega n. Okay, 2 pi by omega n. Time period of oscillation, they can ask. So, you can use this formula. And there is one more formula for the frequency. There is one more formula for the frequency, right? Which is what? 1 by t. Okay, 1 by t. Uh, 1 by 2 pi. Oh, basically we can write it like this, omega 2 pi by. Omega n divided by 2 pi, and it will become what? It will become 1 by 2 pi under root k by m. And remember its unit, in hertz, right? So if they ask the natural frequency, please check the options whether they have given the natural frequency in radian per second or in hertz. If they asked in hertz, you have to use this formula. If they asked in radian per second, then you have to use this particular formula. Clear? So be careful while writing the frequency formula. Okay. So please check the units. If they asking the frequency in hertz, use this particular formula. In radian per second, use this particular formula. Okay, great. Any doubts? Any confusions? Okay. So after this we'll discuss one more thing. See, we have a different kind of vibrations are there. See, a longitudinal vibration, transverse vibration, and also what? Torsional vibrations, right? So first of all, we'll discuss longitudinal. Okay, longitudinal vibrations, then transverse, right? Longitudinal, transverse, and torsional, right? See, let's suppose this mass is attached to this rod. In the transverse case, it will be like this. Mass is kept here. See, longitudinal basically means what? The vibrations are in this longitudinal directions, but here the vibrations will be in the perpendicular direction. Vibrations will be in the perpendicular direction. See, because of this mass, this cantilever beam will what? Vibrate like this. This will be there, right? And here it will be up and down will be there, but the vibrations are in the longitudinal direction, but here it is in the perpendicular direction. And in the torsional vibration, see, if a rotor is attached, like this, right? Now be careful about writing the formulas, right? See, first of all, always remember some important points. Axial stiffness, Ka, I am writing like this, AE by L, right? Here the bending stiffness, KB EI by L. Okay, EI by L, right? And here torsional stiffness T by theta, it will be GJ by theta. Like this will have a torsional vibrations, right? This is clear to everybody. Oh, G theta by L here, because KT equals to T by theta, na? It will be GJ by L. Yes. Clear? Now see, please be careful while writing these things. Very important. See, what is the stiffness? It is the torsional stiffness. Right. What is the stiffness? Can you tell me what do you mean by stiffness? Can anybody tell me what do you mean by stiffness, guys? Please, fast. Deepak, tell me what do you mean by stiffness? What do you mean by stiffness, guys? Tell me. See, three different cases we are having: longitudinal, transverse, and the torsional. But what actually stiffness basically means? Can anybody tell me? How do you define the stiffness? See, always remember a general formula. Here I will write it. Here only I will write stiffness. See, please be careful while writing the stiffness. Here I am writing stiffness, always remember, equals to load divided by deflection. Load divided by deflection. Okay, load divided by deflection is nothing but the stiffness. Please remember this particular formula. Okay, always remember. Okay, see, natural frequency, time period, okay, 2 pi by omega n, and here 1 by t for the frequency. But in the hertz, unit is very important, in the hertz. Okay, clear? Now, please, these terms are also important for the strength of material point of view also. Strength of material point of view, it is also important, right? Now see, now if you want to write the, what, the stiff natural frequency, if you want to write, you can use what, K by M. Okay, K by M you can use. Okay, here also you can use omega n under root K by M, and here also you can use omega n equals to under root K by M. But please remember, what is K? Torsional stiffness, transverse stiffness, and longitudinal stiffness. And specifically for the transverse vibration, see, for the civil engineering student, maximum time they will ask this one, important. This one is important. For the civil, this one is important because you can easily relate with this one. Because in the structure, most of the time you will have a cantilever beam, right? Most of the time you will have a cantilever beam, you can relate with that. Okay. Again, one more important point here. Apart from this, you can also use one more formula here. See, apart from this, you can also use. See, here only I am writing. Here, omega n equals to. See, when we write mg equals to what? Mg equals to k delta, na? Mg equals to k delta. Initially we have written k delta. Mg equals to k delta. See, in the first case here, Mg equals to k delta we have written, na? So here the deformation is like this, so we can calculate delta here. Here it is delta. But what is the delta in transverse vibration? Delta will be the deformation of the cantilever beam, and you remember the deflection formula from the strength of material. Remember the deflection formula and the strength of material, guys. Okay, just you remember the formula for the cantilever beam in which point load is acting at the free end. Point load is acting at the free end. So just remember that particular formula, and you can put like this. In place of k by m, you can put g by delta. G by delta. From this formula you can also calculate what? Natural frequency, right? Here KT will be there, here bending stiffness will be there, here axial stiffness will be there. Okay, clear? Here also you can put omega n, here also you can put under root G by delta. But for here delta you should know. How you can calculate delta in this case? See, AE P, it will be like this. Okay, PL divided by AE. It will be like this. Okay, clear? Please remember this particular formula, delta P into L divided by AE for this longitudinal vibration. For transverse vibration, delta formula from the strength of material. Okay, whatever the beam they have mentioned, let's suppose here cantilever they have mentioned, point load at free end they have mentioned. So please remember the formula for the deflection of a cantilever beam when subjected to point load at the free end. Okay, so here delta from SOM, right? Please be careful while writing the values. Okay, so we have covered this torsional vibration also part. Transverse and this longitudinal vibrations. I hope this is clear, right? Clear, guys? Please note it down fast. Please note it down fast. Clear? Great. एक बार कंफर्म मैसेज करो क्लियर है, सभी को क्लियर है तो आगे हम बढ़ते हैं इसी में. So if vibration part is finished, now we'll come to the dynamics part. Guys. We'll come to the dynamics part. Very, very important, and we'll see the important relations, right? In engineering mechanics, relations are very important. Guys, please focus on this particular point. Relations are very important. How you can utilize those relations, that is also important. See, let's suppose question comes in front of you and immediately you have to decide which relation I have to use, right? And how the decision can be made? Just by checking whatever the data are given and what is the unknown. Is there any relation between those things? Yes, if there is any relation, please use that, right? Okay, belt and pulley friction, these topics are also there. See, in the mechanical syllabus, they have added these topics. Application of friction, in which they have added belt and pulley. They have added for the mechanical engineering student, right? So we'll discuss the belt and pulley. A very small point that we need to discuss here. Okay. See, let's suppose there is a pulley here, and let's suppose this is the belt. There is a T1, there is T2. Basically, one is tight side, another one is what? Slack side. But can you tell me which one will be tight or which one will be slack? Can anybody tell me? Fast, guys. Tell me fast. Which one will be tight or which one will be slack? First of all, you need to understand how to decide whether it is slack or tight side. On what basis you can decide? On what basis you can decide? Tell me fast. Guys, tell me fast. On what basis you can decide? On what basis you can decide whether it is tight or slack? See, it's totally dependent upon the direction of friction. See, Deepak, for that you need to understand what is the direction of rotation of the pulley, first of all. See, actually there are two cases that we need to understand. There are two cases. Okay. Let's suppose this is your pulley. This is your pulley. Okay. Now, first of all, you need to understand rotation. Yes. First of all, we need to understand what is the rotation. So, rotation is the prerequisite. Before deciding whether it is tight or slack, the prerequisite is what? The rotation. We need to understand the rotation sense, right? But before that also, you should understand one point. whether pulley is driving the belt or belt is driving the pulley, right? See, now in this case I am assuming pulley is driving the belt. Okay, first of all, see, I am drawing the belt like this. This is my belt, right? This is my belt, this is my pulley. And case 1, I am considering pulley is driving the belt. Okay, this is very important, guys. First of all, you need to understand this particular point. Whether the belt is driving the pulley or pulley is driving the belt. So now I have confirmed that this particular point, pulley is driving the belt. Now I am deciding the rotation. Let's suppose it is clockwise rotation. Pulley is having a clockwise rotation. Now see very carefully, please, guys. Pulley and belt is having a contact. Definitely that contact is what? Rough. So definitely coefficient of friction they have given. But we need to understand the direction of friction first of all. See, frictional direction will be such that it will oppose the relative tendency of motion. Okay. So on the pulley, frictional direction will be what? In which sense it will be? Clock or anti-clock? Guys, tell me first. On the pulley, frictional force will act in clock or anti-clock? Yes or no? Guys, tell me first. It will be on the frictional force on the pulley will be in the clock or anti-clock? In which direction? In which direction frictional force will act on the pulley? Deepak, yes, anti-clock. Okay, yes, definitely anti-clock. Why anti-clock? Because the relative tendency of motion of a pulley is in the clockwise direction. Frictional force will act in an anti-clockwise direction. Then only it can oppose the motion of a pulley. Clear? But what is the direction of force, frictional force on the belt? It will be on the clockwise direction. It will be on the clockwise direction. Clear? It will be on the clockwise direction. Now, please carefully observe. It is the tension. In both the sides, tensions will be there. Now, just use your common sense. Just use your common sense. This is the frictional force. This is the frictional force that we are having. Now, just use your common sense. Here, frictional force is acting here and tension is also acting here. So, just to balance this particular thing, this value has to be more. Correct? See, frictional force is acting in this direction. So, here T is acting, frictional force is also acting. Two things are there. So, to balance both these things, T has to be large. Right? This T has to be large. So, this is what? Tight and this is what? Slack. Clear? Guys, Deepak, it is clear? Sitwij, आपको clear है? Yes. Okay, clear. So always please be careful. Pulley is driving the belt. On that scenario, we can say this is the tight slide. In shortcut, you can understand. Sir, whenever the anti-clockwise rotation is there, this direction will be what? Tight side. But it is a shortcut that you need. But if you know the concepts, then it is very easy to understand whether this will be tight or this will be tight. Then it will be very easy. Otherwise, you have to just mug up all the things. Otherwise, you have to mug up all the things, right? You have to remind, always you have to learn each and everything. Because it is very basic, just please understand the concept. It is not necessary that each and everything you have to learn or mug up all those things. Okay, but just a basic is there, so definitely you should understand the concepts, right? But here, please be careful. So here, let's suppose I am taking a smooth pulley. Then both sides will be T. Correct? Obviously, both sides will be T. Here it is the rough pulley. Right? Now, Please observe the next point. This is the pulley driving the belt. Next we will see a belt driving the pulley. Okay, belt driving the pulley. Now see. Okay, now belt is driving the pulley. Let's suppose belt is moving. Assume belt is moving in the clockwise direction, right? First of all, assume belt is moving in a clockwise direction. Okay, great. Now, belt is moving in the clockwise direction. So if the belt is moving in the clockwise direction, frictional force will try to oppose it, right? Frictional force will try to oppose it, and here the frictional force will be on the pulley will be like this. Okay, now please be careful. Okay, now definitely tensions will be there on both the sides of a belt, but which side will be tight side? Tell me first, which side will be tight side? Which side, left or right? Left or right? Which will be tight side? Left or right? Which side? Fast answer do, fast answer do. Which one will be the tight or slack? Left or right? Right, absolutely correct. Okay, clear? Now the concept is clear to you? Okay, great. So first of all, please confirm that whether pulley is driving the belt or belt is driving the pulley, right? This is the case. And now, next, see. Now, let's suppose you have decided tight and slack side, right? Let's suppose this is T1, tight side, this is slack side T2. Then there is one important relation between both of these things. T1 tight side divided by slack side equals to e to the power mu theta, right? Now, some important points for this formula you need to understand. First of all, theta you have to take in radian. In radian, you need to take this value in radian, right? Theta value you have to take in radian. Clear? Theta value you have to take in radian. Okay, great. See, then second, applicable for formula is also applicable for non-circular section also applicable for non-circular section. Okay, it is not necessary that it has to be a circular pulley, or it may be some another thing, it may be non-circular thing. Okay, so it can also be applicable on those sections, right? It is not necessary that it is always applicable whenever a circular pulley is there. It is not a condition, right? Now let's suppose it is a circular, so T1 and T2 does not depend on radius of pulley. Right? Radius of a pulley, see, there is no relation of radius of pulley with T1 and T2, right? Whatever the radius will be there. So they will be asking like this, if I increase the radius of a diameter, what will be the changes on the tensions? No changes at all, right? There is no effect on the T1, T2. No effect on the T1, T2, right? Now see, it is clear. Okay, theta is what? The contact angle. Okay, fourth point, theta. Okay, take for smaller pulley, take for smaller pulley. Why we have to take for the smaller pulley? See, smaller pulley will have a highest chances of what? Slipping. Slipping will have a maximum chances on the smaller pulley. Slipping has a maximum chances on the smaller pulley only. That's why we have to take the theta value for the smaller pulley only, right? This is very important. Okay. So always remember, whenever they are giving a two pulleys, see, whenever there is connection, smaller pulley and a large pulley, so please be careful. You have to take the theta value for the smaller pulley only, right? Okay. So this formula, for this formula, these 3-4 points you should always remember. Correct? Theta in radian applicable for non-circular section also. T1, T2 does not depend on radius. And finally, take theta for the smaller pulley, right? Now see, this is what a belt pulley arrangement. It is what open belt pulley arrangement, right? It is your open belt pulley arrangement. Open belt. Next, this is what crossed. Cross belt, right? So please be careful while understanding both the open and the cross belt. In the open belt and the cross belt, there are some specific points that you need to understand. What are those? In the cross belt, you will see the angle will remain same for both the pulley. Angle will be same. What is that angle? Actually, angle made by this belt. Angle made by the belt for both pulleys will remain same in case of cross belt. But in case of this open belt, angle will be smaller for the smaller pulley. Angle will be smaller for the smaller pulley. So always remember, when we are using this formula, na, so take the theta for smaller pulley. So in case of open, the smaller pulley will have a smaller angle, obviously. Okay, but in cross, both will have a same angle. Both will have a same angle, right? And also, this crossed, see, if you talk about the frictional resistance, see, in the formula itself, theta, frictional resistance is proportional to theta. Is proportional to theta, right? This is very important. Frictional resistance is proportional to theta. If theta is less, so obviously frictional resistance will be less, right? So note it down fast, guys. Please note it down fast. Okay, note it down fast. Okay, great. Now see, so we are talking about the open and the cross. Okay, angle, lap angle, basically we will say contact angle or lap angle. Okay, in case of open, both are having a different contact angles. Here it will be same. So we'll write it here. Same lap angle. Here we will say different lap angle. Okay. It is having a less power transmission capacity. Please remember this particular point. Less power transmission capacity. Less power transmission capacity, guys. And here, high or more power transmission capacity as compared to open. More power transmission capacity. Clear? So please note it down, this particular points, very important. In objective they can ask. In objective questions they can ask this particular thing. Okay, now next part is screw jack. Okay, next part is screw jack. Again, very important. Direct formula based questions will be there from this topic also. Direct formula based questions. Okay, direct formula based questions you will find out in this topics also, right? See, what is screw jack? I think in your life you have definitely seen, if you are mechanical engineer, you have definitely seen this particular screw jack. Okay. Okay, as a mechanical engineer, you should know how the screw jack would like. Okay, what is the overview? How the screw jack will look like? You should know about this thing. See how the screw jack will be operated. See, we'll apply a force here. Okay, we'll apply a force here in this direction. This is the handle, and basically when we are applying this force, obviously we are providing what moment? We are providing the torque, right? We are providing the torque. If we are providing the force in such a direction, the torque will be acting at this bolt on the screw jack, right? So torque will be acting here only. So we need to calculate here. Two cases are there. We need to calculate what? We need to calculate the torque requirement or force requirement at the handle, so that we can raise the load. Okay. And there is also one more important point. What is the condition of self-locking? What is the condition of self-locking? This is also important point, right? What is the condition of self-locking? This is also important point, right? Clear? So first of all, please be careful and please remember this particular point. Okay, this the force P is acting like this. This force P is acting. Let's suppose here it is mentioned A. I am mentioning write it like this: length of a handle. This is what length of handle, right? And this P is acting. Now you need to understand how to calculate the force required at the handle, so that we can lift the load. Okay, so that we can lift the load, right? See, so but before that you should understand what is pitch, what is lead. Okay, see, when we say pitch, it is the axial distance. First of all, be careful. It is axial distance measured between two consecutive threads, right? Between two consecutive threads. Okay, it is the axial distance measured between two consecutive threads. And what is lead? Axial distance through which a screw will advance is when it turns one complete rotation or revolution, like this. So screw, in case of screw, you should understand what is pitch, what is lead. And important note point, lead and pitch are equal in case of single threaded screw. In case of single threaded screw, right? So always remember this particular point. Pitch, the axial distance measured between two consecutive threads, right? Consecutive threads. Lead, angle, distance, axial distance through which the screw will advance when it turns one revolution. Clear, guys? It is clear? Okay, great. Now see, how to calculate the helix angle. Actually in the threads there will be some helix angle will be there. Let's suppose this is alpha, this is lead, and this is what pi dm. Okay, this is the mean radius. Actually that is what the mean radius, tan alpha. This is what helix angle, L by pi dm. So if the screw jack is what single threaded, if it is a single threaded, then you will use in place of lead what pitch. Okay, in general what is the formula for a lead? N into P. N into P. If it is a single threaded, N value will be what? 1. Okay. For double threaded, N value 2. Simple. For double threaded, N value will be 2. So I hope this helix angle is clear to you. Now you need to understand the value of force P. Value of force P applied at the handle to lift the load W. So basically on the screw jack, on the screw jack, there will be some load that we want to be lifted up, that we want to be lifted up. Okay, we want this particular load to be lifted up in the vertical direction, right? So for that we are applying a force here. Okay, so actually we need to calculate what amount of force is required. Okay, great. So for that there is one formula that you directly need to remember. P equals to W into R divided by L 10 phi s plus alpha. Okay, very important. Please guys, please note it down. Very, very important. Direct formula based question they will ask from this screw jack. Direct formula based. Hello Yashwindra. Hello. Good evening. So we'll definitely ask the directly formula based questions. Okay, just you need to remember this formula. Actually, see, you are applying the force here. Okay, most of the time students will be confused. See, you are applying the force P here. Okay, at the handle. So they want us, they just want how much force is required at the handle. Okay, so that this load will be lifted in the vertical direction. In this way, you can calculate. Right. So this is the formula. So let's suppose what is the condition of self-locking? Please remember the condition of self-locking also here. Condition of self-locking. So if this alpha is less than this static friction angle, okay. So please first of all mention this particular point here. Angle of static friction. Angle of static friction and alpha. Alpha is what? Your helix angle. So first note it down guys fast. Please note it down fast. Please note it down fast. Clear? Thank you so much, Sevendra. Thank you so much. Okay. So I hope this particular point is clear to you. Now see, if alpha value, see one important point, if alpha value is greater than this friction value, right? If it is happen, then screw will unwind on itself. Okay. See, here you have applied the load. Okay. So definitely load will be lifted. Now, if you just remove the load, and if the helix angle is greater than, what? The friction angle, then it will automatically unwind. Unwound basically means it will again come down to its initial position. It will come down on its own. Okay. Let's suppose you have applied the force, it has lifted up to some distance. Now, if you remove the load, it will again come down. Why? Because helix angle is greater than that of friction angle. Okay. From the analysis, that particular point we got. Okay. So obviously we cannot do the analysis right now, but that particular point for the examination you need to understand. Okay. So please write it down here. If this helix angle is greater than phi s, screw will unwound itself. Okay. But what is the condition of self-locking? So for the condition of self-locking, friction angle has to be more than alpha. For the self-locking, please remember, for self-locking, friction angle has to be greater than alpha. Then we can say it will self-lock. How it will be self-locked? See, now if phi angle of friction is greater than helix angle, then in that particular case you have applied the force, load will be lifted. Now if you remove the load, it will be there only. It will not again come down. It will be there only. It will not come down. Why? Because of this friction angle is greater than alpha. friction angle is greater than alpha. This is the case. Okay, please remember this particular point, right? So now if it is not coming downwards, so if we want this particular load to be again come down, so what will be the case? Again we have to apply the force, but what is the magnitude of that particular force? See, that particular magnitude of force will be what? See, value of force P, please write it down like this, value of force P to lower the load, to basically make the load in the down, to make the movement of load in the downward direction, right? So for that P value will be equals to W into R divided by L 10 phi s minus alpha, right? Phi s minus alpha. Okay, so this much amount of force will be required. This much amount of force will be required. Okay, always remember this much amount of force will be required to just lower the load. And if you want to raise the load, this much force is required. Correct? And if you want just turning to be there, okay, if you want just see, if you apply the load, let's suppose if you apply the load will be raised. Okay, you applied the effort basically, and because of that effort load has raised. Now if you want it just to turn on its own, then in that particular case you have to keep the angle of friction what? Kinetic angle of friction. Okay, because in the dynamic case you cannot put the static angle of friction. For the dynamic case you cannot put static angle of friction. Okay, always remember this particular thing. Okay guys, great. Now, so I hope this particular point is clear. So both these points are very important for you. Okay, both these points are very important for you. So please note it down fast. Then we'll come to the our dynamics portion, right? The last portion of this session will come to the dynamics portion. Clear? So always remember the values, right? Formulas very important. And here please mention this particular point, the mean radius. Mean radius of a screw. Mean radius of a screw, guys. Okay, it is the mean radius of a screw. In both the formulas, this RM, this is RM. Mean radius of a screw. Okay, this is what mean radius of a screw. Please note it down first. Okay, there is one more formula here. Actually, there is one more formula. Mechanic, here you can also write it one formula for the efficiency. Tan alpha divided by tan alpha plus phi. This formula you can remember for the efficiency of screw jack. For the efficiency of screw jack, you can remember this particular formula. Right? So please note it down. Okay, clear? I hope this particular thing is clear to everybody. Now moving to the next part, that is the dynamics part. Okay, dynamics part we are having two things. In dynamics part we are having two things, kinematics and kinetics, right? Everyone knows this kinematics and kinetics. See, kinematics we deal with what? Displacement. We deal with velocity, we deal with accelerations, all those things we'll discuss. But here apart from motion plus force is also considered. In kinetics we also include the force in our analysis, right? So this is the point that we need to understand first of all. So basically in the starting of the mechanic itself, we have said we have two things, particle and rigid body. Okay, so we'll talk about particle, kinematics of particle first of all, then we'll discuss what? This kinetics part, then we'll discuss the kinetics part. Okay, for the particle and rigid body. For both the things we'll discuss separately. Now moving to the next part. See, very important, kinematics of particle. See, kinematics of particle, two things are there actually. First is rectilinear translation. Right, and second one is curvilinear translation. Okay, clear? First is what? Rectilinear translation. Next is what? Your curvilinear translation, right? Now see very carefully. In the rectilinear translation, two things are there. Okay, basically a few things basically we want to discuss in the rectilinear translation. Some equations that we that you should always remember. Okay, because when we say a rectilinear translation, it means straight line motion. It means what? Straight line motion. Okay, but in the curvilinear, what does it mean? It means that the motion will have a curved path. The particles will have a curved path. It will move along a curved path, but in rectilinear, it is moving in a straight line. Obviously, clear? Now, see, in the rectilinear translation, see, we'll have some equations like velocity equals to dx by dt. Okay, acceleration equals to dv by dt. And one more equation, acceleration into dx equals to v dv. See, these three are fundamental equation of motion in case of rectilinear motion. In case of rectilinear motion, these three equations are fundamental equations. You can use any of these equations. These are fundamental equations, okay? Fundamental equations of motion. Right, always remember. So if it is a constant acceleration, we'll have some equations of motion, and if it is a constant velocity, then we'll have a different equation of motion. But these three are the standard equations, fundamental equations. You can apply anywhere. You can apply anywhere. Okay. Now it is very easy part because in the school level of physics, you have already discussed that. So I will be writing just in a short. I will writing if acceleration is constant. If acceleration is constant, you will write equations of motion like this: v is equals to u plus at, right? And s equals to u t plus half at square, right? And if we talk about another equation, it is what? U square plus 2as. Like this, you will have equations. Clear? You will have equations like this if acceleration is constant, right? So this point you should remember. But now come to the curvilinear part. Come to this curvilinear part. Motion is along the curved path. Particle will follow. Particle will have curved path. It will not be a straight path. Okay, it is a curved path. When it is a curved path, two important parameters will come: tangential and the normal. Tangential and normal component will come. See how it will come. See, okay, see, very carefully observe this particular point. Very, very important. This is x, this is y. Like this, it is a curved path. Yes or no? It is a curved path. Okay, great. Now, let's suppose at this moment I am considering. So, it is what? Tangential direction. So, if there is, obviously it is a curved path. So, let's suppose I am assuming this particular point. So, let's suppose it displaces a very small distance. Displacement, let's suppose consider a very small displacement, right? If you consider a very small displacement, okay. So, whatever the displacement you consider, it will be some an arc, and arc is associated with circle, and circle for what? For the circle there will be some center of curvature. See, this will be the curvature, na? Because the path the particle is following, it is curved. So curvature will be there. And for that curvature, a center of curvature will be there for sure. Okay. Let us assume this is the center of curvature. This is what? Center of curvature. Okay. Now see. This is the velocity direction. This is the velocity direction. Okay. Always remember. What is the direction of velocity? It is the tangent to the path at any instant. At any instant, if you take a tangent on the path, it will show the direction of velocity vector. It will show the direction of velocity vector. So what is the direction of velocity vector? You just need to draw the vector. You just need to draw the tangent actually. You just need to draw tangent at the path of the particle you need to draw. On the path of the particle you need to draw the tangent, right? If you draw the tangent, you will get the direction of velocity vector. Okay, clear. Now, if I draw same thing, see again. So this is what your tangential direction and this is what your normal direction. See, this is your center of curvature. Let's suppose O I am considering this center of curvature. So this is your tangential direction. Along the tangential direction, there is some tangential acceleration, and there is one normal acceleration, right? So please be attentive in the session. It is very important to understand what is the tangential acceleration, what is normal acceleration. It will be there in your theory of machine also. In theory of machine, you will also see this thing, right? Okay. Now see. As we have said, tangential and normal acceleration, first of all, understand the formulas of this tangential and normal. R alpha and the normal will be what? V square by R. What is R? R is nothing but radius of curvature. R is what? Radius of curvature. Okay. Clear? This is clear to everybody? Okay, great. So tangential acceleration is this one, normal acceleration is this one, right? But important thing is that what is the directions? Direction is very important, guys. Direction along velocity vector. Along velocity vector. Direction is along the velocity vector, right? When the particle is what? Accelerating. When the particle is accelerating, direction along velocity vector when particle is accelerating. Right? And its direction is always towards the center of curvature. Always towards the center of curvature, guys. Please note it down fast. It is always towards the center of curvature. What? The normal acceleration is always towards the center of curvature. So if there are this tangential acceleration is, normal acceleration is there. So these are the formulas. Alpha is what? Angular acceleration. Alpha is what? Angular acceleration, right? You already know what is alpha. Angular acceleration, okay? So I hope this particular thing is clear. Now, come to the next part. So in the kinematics of a particle, we discuss rectilinear translation, curvilinear translation that we have discussed. Now come to the kinetics part. See, in the kinetics, force analysis is also there. Force analysis is also there. See, we are including the force in our analysis, right? What is the fundamental definition of force? What is the fundamental definition of force? Force definition is actually given by the Newtons only, right? From the Newton's first law, we know what is force. Force is nothing but a thing which can change the condition of a body. See, someone says a condition of a body has changed. Yes, it has changed because of the force is acting. So force is nothing but a thing which can change the condition of a body. Force can change the condition of a body. So actually Newton has defined force in this way only, like if condition of a body has changed, so force has applied. because only force has a capacity to change the state of a body. So state is changing, so basically force is acting on the body, right? So in the kinetics, first point that you need to understand, Newton's second law. Right? Force equals to mass into acceleration. Yes, guys, it is very important. But acceleration direction and force direction should be same. Okay, this is very important. You need to understand both force and acceleration are vector only. Both are vector only. Right? This is the Newton's second law that you need to understand. Very important. Now, so Newton's second law can be applied in rectangular coordinates also and in the normal and tangential component also, right? See, if this is our coordinate axis, let's suppose y, x, and let's suppose this is z also. So if along the horizontal direction I am considering, so I will be taking the forces along x, summation of force along x equals to mass into along the x direction. So always remember, direction of acceleration and the force should be same. Direction of acceleration of force and acceleration should be same. It is very important to understand, right? It is clear? Great. So this is the Newton's second law. It is applied in rectangular coordinates. It can also applied in normal and tangential components, right? Okay. How? See, when we say it as this is the curvilinear path, so this is the tangential acceleration, this is what normal acceleration, right? So we can define Ft as mass into tangential acceleration, and normal force we can define like this, mass into normal acceleration. Like this we can define normal force and the tangential component of force. Like this we can define. Clear? So first thing in kinetics is what? Newton's second law. Second important thing, work and energy relation. Very, very important. Work and energy relation. Work and energy relation. See, work and energy relation, how we can define? See, when we say work and energy relation, it is very important. How? See, whatever the work done is there, it will be equals to change in kinetic energy, right? Kinetic energy final minus kinetic energy initial, because when we say the change, it is always final minus initial, right? It is always final minus initial. Okay, please remember this particular thing. So work done equals to change in kinetic energy. We can also represent this particular formula in a different way. How? See, work done equals to net force multiplied by the displacement equals to this kinetic energy difference final minus initial. Final minus initial. Clear? This particular point is clear to everybody, right? So this is the work and energy principle that you need to understand. So note it down fast. Next we'll discuss what? The impulse. Okay, next we'll discuss the impulse part. Clear? Okay. Next we'll discuss impulse momentum. Okay. In the impulse momentum principle, see what is the concept. You already know the first Newton's second law. Okay, from the Newton's second law we can write it like this: F equals to what? Mass into acceleration, right? So as you know, acceleration can be written like this: dv by dt, right? it will be like this. Okay, if we do the integration, see, it will be what? Final minus initial. So the change of momentum equals to what? The force. So basically here it is what? Impulse. Actually, force multiplied by a very short period of a time, it is what? Impulse. Clear to everybody? It is what? Impulse, right? So this is impulse momentum principle that you can apply when you see. Most of the time confusion will be there. Which formula to be used? See, first, Newton's second law. Whenever acceleration and forces are there, you need to apply this formula. Okay. Now, if they have given the displacement, so you can use this. Velocity and displacement they have given, you can use this. Okay. And if they have given the time also for which this force is acting, then you can use impulse momentum relation. Clear, guys? Great. Now, see, one more concept here. Conservation of energy. Conservation of energy, you need to understand. Okay, conservation of energy. See, in this concept, first of all, we are assuming that there will not be any friction. No dissipative effects will be there. No dissipative effects, right? No friction will be there. Energy is conserved, right? So if energy is conserved, okay, we are talking about the mechanical energy. So if energy is conserved, we can write it like this: potential energy plus kinetic energy is what? Constant. Okay. So how we can use this particular relation in our numericals? See, they will give a situation in which one body is moving from one position to another position, and they have said energy is conserved, or they didn't give any coefficient of friction or dissipative effects. So in that scenario, we are assuming the conservation of energy is there. Okay. Now let's suppose body is moving from one position to second position. So whatever the body is moving, how the body is moving, whatever the location the body is moving, in which location they are moving, it doesn't matter. See, body is moving from upward to downward or downward to upwards. Actually, you remember one thing, energy will remain same. Energy of a body will remain same. If we consider the conservation of energy, energy of a body will remain same during its motion also. So during its motion, you can consider any particular position at which you can calculate total energy and compare that energy with another location energy and equate it, right? So let's suppose, for example, body is moving from location 1 to location 2. So let's suppose at location 1, potential energy plus kinetic energy, you can write potential energy plus kinetic energy, you can write 1 1. Okay, this is the energies available at the location 1. So at location 2, potential energy 2 plus kinetic energy 2, you can consider. So you have location 1 energy, location 2 energy. As we have said, energy is conserved, we can equate both these terms. Okay, so we can equate. So total energy at 1 equals to total energy at 2, right? So how we can write it? This. Right, like this we can use the conservation of energy principle, right? So please note it down fast, guys. Please note it down fast. Note it down, guys, fast. Done, everyone? Okay. So just the few topics, few parts is left. Okay, just few part is left. Okay, see, we'll also discuss the momentum. Okay, basically the linear momentum. First of all, we have to write, right? Linear momentum, we remember, mass into acceleration like this. Force is equals to rate of change of momentum. See, let's suppose linear momentum I am representing with P. Linear momentum I am representing with P, and linear momentum is having the same direction as the direction of velocity. Whatever the direction of velocity is having, same direction linear momentum is also having. Now, come to the second part, moment of momentum. Or we can say angular momentum. Right? See, in this thing, very important. Let's suppose I am defining it with h. Angular momentum I am defining with h. So it is said what? The moment of momentum they have said. They have said moment of momentum. See, h equals to r cross momentum. What is the momentum? mv. Right? This is okay, clear? What is the moment of momentum? R cross mv. So when you say moment of force, you will do what? R cross f. When you say moment of see, when you say moment of force, you will say what? You will say R cross f, right? It will be like this. You will say, okay, it is clear. It is clear to everybody. So when you say moment of force, it is nothing but R cross f. Now we are saying moment of momentum, R cross multiplied by cross, basically cross product by the linear momentum. What is that? mv. Okay. Clear. Okay. Now you need to take what? This is what? Moment of momentum. This is the formula. Now, as we have seen, the rate of change of linear momentum is what? Force. In the similar way, rate of change of angular momentum represents what? Can anybody tell me fast? As we have seen here, as we have discussed here, the rate of change of linear momentum is nothing but force. But what does it mean by the rate of change of angular momentum? Anybody? Can anybody tell me what is the rate of change of angular momentum? See, if you do rate of change of angular momentum, you will get what? dr by dt cross mv plus r cross d by dt of mv. Right? Now see, very carefully observe this particular thing. Okay, dr by dt is nothing but the velocity vector. Okay, here r cross, here d by dt of mv. d by dt of mv is nothing but the force. Okay, great. Now see very carefully, velocity vector multiplied by the momentum. See, velocity and momentum both are having the same direction. So if you take the cross product, you remember when you open the cross product, sin theta will come, and as both having the same direction, so definitely theta will be 0. So this term will be what? 0. This term will be what? 0. Okay, guys. So rate of change of rate of change of angular momentum will be what? R cross f. And you remember what is R cross f? Moment only, na? It is what? Moment only. It is nothing but moment only. So moment equals to rate of change of angular momentum. Guys, please remember very important thing. force equals to rate of change of linear momentum and moment equals to rate of change of angular momentum. Put a star mark here, very important. Note it down fast. Fast note it down, guys. Please note it down fast. Okay, clear? Now see. We'll discuss a part of pure rolling error. Quickly we'll discuss the pure rolling part here, okay? Let's suppose it is having a pure rolling motion. It is having a pure rolling motion. Let's suppose it is having a pure rolling motion. And if it is having a pure rolling motion, see, if it is having a pure rolling motion, so let's suppose in one complete rotation, whatever the distance it has traveled, it will be equals to what? Let's suppose in one complete rotation, how much distance it will travel? 2 pi r. Obviously the circumference value, see, it will start the motion from here, and after complete one revolution, the distance traveled will be what? The circumference only. Deepak, great, Deepak, great. 2 pi r, it is the circumference value. See, when the wheel is taking one complete revolution, right? Wheel is taking one complete revolution, circumference distance it will travel, right? Great. So, it is the distance traveled by the disc, let's suppose. Let's suppose in time t it is traveling. In time t it is traveling, right? So if you are calculating this velocity, okay, if you are calculating velocity and doing ds by dt, okay, what you will get? What you will get, guys? Tell me fast. What you will get? What you will get? See, we are calculating velocity, okay? See, this is the distance, okay? See, this is the distance we are having. Velocity will be nothing but the distance divided by time, 2 pi r divided by t, right? So if you see here, velocity will be what? R into omega. Omega is nothing but the angular velocity. Omega is nothing but our angular velocity. How? See, omega is our angular velocity. See, omega is what? D theta by dt. Whatever the angular displacement is there, that point we need to consider. See, omega is equals to d theta by dt. Rate of change of angular displacement. See, when the rotations are there, you need to check the angular displacements. Whenever the translation is there, you need to check the translation. Okay, whatever the distance has traveled during that translation, you need to check. But in the angular terms, you need to check the angular displacement, right? So be careful while using the linear terms and the angular terms. Okay, you need to have some basic idea, right? Now we'll write it down all the equations in linear as well as the translation terms, right? So please note it down up to this point, then we'll note it down each and everything in rotations also. Okay, see, let's suppose this is your rotor, right? So theta is what? Angular displacement. Okay, theta is what your angular displacement, right? Clear? Theta is what your angular displacement, correct? Now, see, if you want to calculate the angular velocity, you need to calculate d theta by dt. Unit radian per second, guys, radian per second, okay? Angular acceleration, rate of change of angular velocity, radian per second square, okay? Omega angular velocity, angular acceleration. Angular acceleration, clear? Theta, omega, alpha, this point you need to understand, right? Okay, great. Now, see, in the rotation case, you need to understand that moment, summation of moment equals to what? I alpha. See, in the what? In the Newton's second law, we have having what? Force equals to mass into acceleration. In Newton's second law, na? Force equals to mass into acceleration. Here we are having moment equals to mass moment of inertia into angular acceleration. Always remember this particular thing. Mass moment of inertia, not area moment of inertia. It is the mass moment of inertia. Clear, guys? It is the mass moment of inertia multiplied by the angular acceleration. So these important terms you should know about the rotation. Okay. These important terms you should know about the angular acceleration, angular rotation part, right? Okay, this is clear. This is clear. Okay. So see, for the pure rolling, always remember in complete rotation it will travel 2 pi r. So whenever pure rolling case is there, velocity will always be v is equals to r omega. Okay. Always remember, each and every particle of a pure rolling will have a 2 pi r velocity, r omega velocity. See, center is also having r omega, this particle is also having r omega, this is also having r omega. Each and every particle is having r omega velocity. Okay, each and every particle. Clear? This is the point that we need to understand in pure rolling. Each and every particle is having a r omega velocity. Okay, all the particles like this. Okay, so now consider this system as a what? Translation. We can consider it as a translation. Okay, plus we can consider a pure rotation. So always remember, pure rolling can be considered as a translation, summation of two things, translation plus rotation. Translation plus rotation. You need to consider this particular point very carefully. Okay, how the rotation will be there? See, let's suppose it is a clockwise direction. So what are the velocities will be there? See, tangential velocities will be there. This is r omega. This will be r omega. This is what? R omega. And this is what? R omega. So rolling is nothing but the combination of translation plus rotation. Clear? Deepak, it is clear to you? Translation plus rotation, right? It is the combination of pure translation plus rotation. Clear? It is clear, everyone? Okay, great. So you need to understand the rotation about the fixed axis, right? This part is also important for the gate examination. Okay, right? And this kinetics formulas, impulse momentum principle, right? This work done and energy relation, right? And Newton's second law. This law is equally applicable for particle and also what? The rigid body. For rigid body, for particle, both the cases, this Newton's second law formula will be applicable. Work and energy relation is applicable, and this impulse momentum relation is applicable. Okay, for the rigid body also. But in the rigid body, you will see the rotations and pure rolling part. One last thing that you need to understand, the D'Alembert principle. In some cases, you will require the D'Alembert. Okay. Okay, see, let's suppose this is a block moving with the acceleration a, right? Now for this body, according to Newton's second law, NSL, Newton's second law, we can write like this: force equals to mass into acceleration, right? This is the point. But according to D'Alembert, guys, please pay attention here. According to D'Alembert, what will be there? Simply whatever the force is there, add one more force. That particular force is known as what? Inertia force. And how the inertia force will come? See, how the inertia force will come? Opposite to the direction of acceleration, inertia force will come. Opposite to the direction of inertia force, opposite to direction of acceleration. Inertia force will act. So if we add all the forces, whatever the force that is acting on the body, right? Whatever the force that is acting on the body and inertia force. Obviously inertia force in the negative sense, because force is acting in this direction. Force is acting in this direction, guys. Force is acting in this direction and acceleration is also in this direction, like this, equals to 0. So D'Alembert is nothing but the another representation or interpretation of Newton's second law only, right? Another representation. How? See, Newton's second law, force equals to mass into acceleration. What D'Alembert has said, whatever the forces are acting on the body, just add the inertia force. Just add the inertia force on the forces, right? Whatever the force is adding, whatever the total force is acting on the body, add the inertia force and the total summation will become 0. See, inertia force will act opposite to the direction of acceleration and inertia force value will be equals to mass into acceleration only. Clear? This particular point is clear. So according to D'Alembert, whatever the forces are acting, just add the inertia force also and total summation of forces will become 0. Total summation of forces will become 0. So this is the D'Alembert principle, guys. Done? Clear? Last, the topic is Lagrange equation. The last topic is what? Lagrange equation, guys. Note it down fast. Lagrange equation. The topic which is recently added, Lagrange see, in the Lagrange equation, you need to understand first of all what is Lagrange function. Kinetic energy minus potential energy. See, this is the Lagrange function, right? This is your Lagrange function. So actually there is a Newtonian mechanics is there, Lagrangian mechanics is there. Okay, various different we can say different scientists were there which actually done some analysis in the field of motion, right? So different mechanics are there. According to Newton, Newtonian mechanics is there. According to Lagrangian mechanics is there. According to Hamilton mechanics is there. Okay, so all those different scientists have done their work on the field of motions, right? So they have given their own point of view according to the different mechanics, right? According to the mechanics, actually they have given their own interpretations, right? Actually all those scientists will having a different opinions, different orientations, or different basically we can say interpretations for the motion. So in that respect, Lagrange is also one of those scientists. Actually, apart from Newtonian and this Lagrange, Hamilton is also there. And it is also equally important, but as far as it is not in our syllabus, will not discuss that about Hamilton. Otherwise we can discuss it on Hamilton mechanics also. But in the Lagrange mechanics, see, you need to understand what is first of all Lagrange function. Then you need to understand what is the equation of Lagrange. What is the equation of Lagrange? Actually, Lagrange has done a superb work. They have given just one equation. From that particular equation, you can get the value of equation of motion just by using one equation only. Just by using one equation only. But before that, you need to understand the Lagrange function, kinetic energy minus potential energy. Okay. So actually, in the system, he considered two types of energies are there: kinetic energy and potential energy. Okay. He considered two type of energies, kinetic energy and potential energy, and he utilizes this function. He utilizes this function for representing the whole equation of motion. For representing the whole equation of motion. Guys, clear? Okay. Just 1 second. We'll take water. Okay. So this is the Lagrange function. See, the equation will be like this: d by dt of del L by del X dot minus del L by del X equals to 0. See, this is the equation that we are having for the Lagrange equation. See, you need to understand first of all X. L we already know. X is what? X is what? The generalized coordinate. Generalized coordinate for the given system. For the given system. See how we can select it. See, let's suppose a simple pendulum case is there. Okay, simple pendulum case is there. This is your pendulum having mass m. So this is theta. This theta is our generalized x coordinate. So in the same way we can define this generalized coordinates for other system also. For other system also we can define this generalized statements or generalized coordinate. We can also define generalized coordinates. So for this situation, this theta is our generalized coordinate. Okay, in this way we'll have a generalized coordinates and we'll solve the equation of motion. Just you need to understand this particular equation: d by dt of what? Del L by del X dot. So X dot is what? You have taken the differentiation of X. You have taken the differentiation of X. That's why it is dot X dot, right? Please remember it is dot differentiation of X. We have considered minus del L by del X. If you use this particular equation, you will directly get the equation of motion. Okay, you will directly get the equation of motion. You will directly get the equation of motion. Clear? I hope this particular point is clear to you. Okay, guys. So we have discussed almost all the things. We have discussed almost all the things, right? So this formula sheet was prepared for you and it will be given to you. Please get it from the Telegram link, whatever the link is provided in the description box. You can get this PDF link. Okay, you can get this PDF and please revise your subject. Please revise your subject very carefully. Please revise all the formulas, all the concepts, all the relations. And at this final time, you have to be very focused and you have to focus on the specific points only, right? This is not a time to study the whole subject with the notes. Just make your own formula sheets. Make your own formula sheets, right? And write down all the formulas and try to solve all the questions of PYQ first of all. Then solve full length mock test. Okay. So I wish you all the best for your GATE examination, guys. All the best from my side. And definitely you will succeed. Definitely you will succeed if you work hard. Okay, guys. Whenever you do work hard, definitely you will get the success. Okay. Please make sure that whatever we have discussed, please note it down in your notebook. Okay. Important formulas should be there. You have to consolidate each and everything at one place, right? remember, let's suppose you are going to the examination hall. Just before entering into the examination hall, your notes prepared, your formula should be prepared, okay, so that directly by seeing the formula sheet you can cover whole subject. You don't need to check your notebook. So formula sheet will help you in that particular position or at particular time. So you can revise the whole subject by just reading 1 or 2 pages, because formula sheets will be there in just 2 or 3 pages, right? So in 2 or 3 pages you will be completing the whole subject. So all the important things will be consolidated at this place. On those formula sheets, all the important points will be consolidated, and please revise it day by day. Daily you have to revise it, right? Okay guys, thank you so much for this particular lovely session, and I hope all of you will get the success and very best for your examination. Thank you so much.